Good morning, everyone. My name is Volodymyr Artemchuk. I represent Pukhov Institute for Modeling in Energy Engineering, where I currently work as a Deputy Director for Scientific and Organization Work. Welcome to the 4th International Conference of Sustainable Futures, Environmental, Technological, Social, and Economic Matters. It's truly a pleasure to see many scientists, experts, and professionals who are dedicated to sharing a sustainable future for our planet. This conference serves a platform for us to come together and delve into the pressing issues surrounding environmental sustainability, technological advancement, social responsibility, and economic consideration. Our goal is to foster meaningful discussion and explore innovative solutions that can lead us toward a more sustainable and resilient future. Today, we have a privilege of hosting the Sustainable Energy Workshop, which is focused especially on the vital topic of sustainable energy aspects and their role in mitigation climate change and achievement a greener tomorrow. We will have the opportunity to learn from leading experts in the field who will share their knowledge, research finding, and practical insight. Ukrainian scientists, like its energy system, demonstrate their resilience every day. And in the near future, we will probably become the most qualified specialist in the field of resilience. Throughout the day, we will examine various aspects of technological energy efficiency measures, policy frameworks, and the integration of clean energy into our daily lives. It's my seriously hope that this discussion will inspire us to take action both individually and collectively towards a more stable energy futures. I recognize each and every one of you to actively participate in the workshops throughout providing conversation and contribute your unique perspectives. This conference is a platform for collaboration and the exchange of ideas that your active involvement will play a critical role in shaping our outcomes of our discussion. I would like to express my heartfelt gratitude to all of the distinguished speakers, programming and organization committee members who have worked tirelessly to make this conference reality. Your dedication and comments to sustainability are truly commendable. Without further ado, let us back to this journey of knowledge, innovation, and collaboration. May our discussion today pave the way for the sustainable future that embraces environmental stewardship, technological advancements, social equality, and economic prosperity. Thank you, and let us begin the 4th International Conference of Sustainable Future, Environmental, Technological, Social, and excuse me, please. Thank you, and let us begin the 4th International Conference of Sustainable Futures, Environmental, Technological, Social, and Economic Matters, along with the Sustainable Energy Workshops. But before we proceed, I would like to highlight a few important guidelines for this conference. The conference is international, and therefore all question, response, and discussion are to be conducted in English. This will ensure effective communication and maximize the participation of attendees from different backgrounds and different countries. Each presentation, including its subsequent discussion, is allotted a total of 15 minutes. We kindly request all speakers to adhere to this time limit to ensure a smooth flow of the conference. However, we note that the chat function will remain active throughout the event, allowing for ongoing discussion and interaction. Thanks for your attention, and let us now begin with the first presentation. Research on the application on the board energy storage on an electric locomotive for quality railway transport. I see authors Lilia Kondratьева and Evgen Rabov. Let's start. Some problems.
Sorry, but we have not seen the presentation.
Yes, some problems. Now, okay. 1 minute, please.
Research on the application of on-board energy storage on an electric locomotive for quarry railway transport. Improving efficiency and reducing harmful effect on the environment is an important task of EU countries and Ukraine. Ukraine is a large mineral resource base with iron ore reserves of 30 billion tons, which about 6% of world reserve. Iron ore raw materials used for the manufacture of metallurgical products are produced by mining enterprise both for domestic market and for suppliers to foreign customers. The constant increase in the cost of fuel and energy resources, the transition of carbon-neutral production, the need to increase the competitiveness of product and improvements in the environmental situation require from the side of mining enterprises wide introduce and implementation of innovative technologies at all stages of production. Today, mining enterprises of Ukraine use traction units produced by Dniprovsky electric locomotive plant. You can see it on the picture. To transform iron ore on electrified section of domestic railways. These machines were developed in 17th, 80s of the last centuries using technologies available at that time. Modernization of traction units, which are carried out by various enterprises, provide for the use of modern equipment, which positively affects their reliability and performance. The main features of the operation of traction units is quarries are listed on the slide. 5. Collateral electric motors and unregulated electric drive of auxiliary system are used on traction units. The above factors cause increased power consumption, taking into account the deterioration of rolling stock, most of which is operated with the extended service life, and there's a problem between traction and energy characteristic in the train task The task of updating electric rolling stock is relevant. The authors proposed a new electric locomotive for quarry railway transport. To achieve its high efficiency, the following technical solutions are proposed. You can see it on the third slide. 4 propositions. Preliminary technical parameters, traction and braking characteristics are shown also on the slide. Here is number axis, load, open, zolot. The block diagram of the electric traction drive on the electric locomotive is shown on the next slide. Here is one. The electric locomotive consists of control section and booster section. On the control section there is an input converter which includes a traction transformer and 4 QS converters. On the booster section there is onboard energy storage system, which is so popular today. They are connected to a common link to constant voltage from which a traction, asynchronous electric drive and auxiliary system of an electric locomotive are powered. This slide shows a diagram of energy flows in the traction system for such an electric locomotive. In traction mode, it's picture A. The priority is power supply from the contact network. If the total load, the tangential power and the auxiliary system exceeds a certain standard of power capacity, then the onboard storage system is connected to the load power. In simplest case, in the electrodynamic braking mode, this mode is figure B. The energy coming from the traction electric drive can be used to power the auxiliary system of the electric locomotive. It's priority usage. Charge the onboard storage system and recovery into the traction network in the case when it's an excess of the total power of the auxiliary system and the power with which the energy of storage device is charged. Thus, the problem arises of determining the parameters of the traction system of an electric locomotive and its individual components. Considering the typical scenarios of the onboard energy storage system, it's shown on this slide. The first scenario is that the power of capacity of the onboard energy storage system is sufficient to accumulate all the energy that generates during electrodynamic braking. The second scenario assumes that the power of the drive is selected from the condition of power compensation in traction mode. The power of the drive in this case is calculated by the expression number 2. To carry out calculation for both scenarios, the flowchart has been developed, which is shown here on the slide. The calculations were carried out for the railway section at example of Poltava-Gok for Expo mining. The moment was carried out by the train with 14 loaded wagons. The type of wagons is 2 BC 905 from the transshipment point to the crucian factory. The best profile is shown at the figure. Here is one. For this best profile, a traction task was solved, and the result of which is determined as the depends of the attractive power, and here is result from time. Further, this dependence was used for analysis according to the studied scenarios of the operation of the electric locomotive traction system. The calculation was carried out for the case when the voltage on the current collector of the electric locomotive was equal 7.5 kilovolt throughout the section. This is an artificial situation that corresponds to the worst case of the supply. Therefore, it is advisable to calculate the parameters of the traction system for such a case. Traction network current was taken as a limitation. The lower figure on the left shows the dependence of the power of the onboard energy storage system from current. The lower right figure shows the dependence of the working energy intensity of the onboard storage system on the current. This storage capacity is about 5,800 kW, and the minimum operation energy intensity is about 60 kW per hour. Mains current is about 600 ampere. Accordingly, in the first scenario, when the storage power is constant and sufficient to receive the braking energy, this power does not depend on the current, and the dependence of the working energy intensity has a nonlinear character, with a minimum of about 600 amperes. These dependencies are shown in green line. In the second case, the power of the storage is selected from the condition of compensation of power consumed from the traction network. The power of storage decreases with the increasing mains current. The operating energy intensity is also nonlinear in nature with a minimum of 700 amperes. In this case, the current power of storage should be 2,800 kW and the operating energy intensity should be about 50 kW per hour. As you can see in the first scenario, the power of the onboard storage system is greater, which potentially means its higher cost. That is, capital investment will be more, which makes this option less attractive. Therefore, we consider it expedient to use onboard storage in the second scenario of operation. The power of storage is selected from the conditions that it will be compensated for the lack of energy from the contact network. Accordingly, in the modes of electrodynamic braking, energy will be both accumulated for the onboard storage and recuperated to the traction network. Thus, the priority option in the second science it requires less capital investment to create an onboard energy storage system. For a more accurate determination of the parameters of the electric locomotive traction system, it is necessary to consider the moment cycle, which includes all stages of working task of electric locomotive. For example, movement of the empty passage from the crushing factory to the transshipment point, maneuvering at the transshipment point when loading, movement of the loaded train from the transshipment point to the crushing factory, and maneuvering during unloading at the crushing factory. Thank you for attention. It was all.
dear science.
Thank you, authors, for presentation. Who have a question?
I have one.
Please.
What can you say about the efficiency of this technology of using energy storage system on the train, taking into account the loss of power, the process of charging and discharging of energy storage system? And the first question, and the second one is, what can you say about the degradative processes of the energy storage systems in time? What is the economic efficiency of such technology? Thank you.
Thank you for the question. We did an extensive study, and the result shows they are saving up to 10% on energy, which we consumes from network network. The second question, we not rated degradation of energy storage because we are at the beginning of this research. I think we will use the traditional approach for this thematics.
Yes, thank you. Any question? If any, I have one question. What can you say about the future perspectives of your research?
Nowadays, traction rolling stocks for quarry railway transport is outdated and it's need to change. And we think that result of our research will be in demand on locomotive building and locomotive repair enterprises of our country. And a new generation of rolling stocks will be included our research.
Okay, thank you very much. Any other question? Any comments, discussion? Okay, thank you for presentation, and let's begin to the next topic. The next presentation is on topic the economic potential of enhanced method of anaerobic fermentation with green ammonia production for European energy market. I see the author Evgeny Shapovalov. And
dear colleagues, hello.
Hello. And now please, we have started the presentation. 1 second, please.
Dear scientists, participants of International Conference of Sustainable Future, I'm glad to present you the presentation on the topic Economical Potential of Enhanced Method of Anaerobic Fermentation with Green Ammonia Production for European Energy Market. And personally for me this is a great possibility and great study because it proves that the method that was developed in Ukraine has huge potential and it has been researched for 10 years. Currently we have challenges that caused by Russian aggression and they are related to energy. Especially this problem is related to Ukraine, but it's not only about Ukraine, it's generally about Europe, and in each country there was changes related to energy problem. Important to understand that Europe has a special policy related to energy prices, and as it can be seen, for example, in Germany, where the amount of alternative energy is developed mostly. More than 50% it's taxes, and the energy itself costs much less than taxes. However, this data is related to 2018, and right now the situation is significantly changed. However, we are still waiting for new data from Eurostat. Also, there is relevance between the prices of energy and number of biogas plants in Europe, and also we can see that the highest amount of biogas plants is in Germany and also in Italy, and the same situation is about prices of energy. It is the highest in Germany and Italy. In Ukraine, situation with amount of biogas plants is pretty poor, and its amount is near to 60. So the biogas plants, even take into account that we have a huge potential, do not in general developed compared to other European countries. This is the locations of biogas plants in Ukraine, and as I told before, there are near to 60 biogas plants in Ukraine. In general, what is important to understand that fully potential of biogas production is not used, so there is lack of biogas plants that are located both in Ukraine and in the EU. And the paper will substantiate the new technologies that may solve this problem of lack of biogas plants, because it proves the high economical potential. So the main idea is to obtain additionally not only biogas but also ammonia that could be used for both as fertilizers and also as energy source. So the idea of proposed technology is that we use substrates with high amount of ammonia, and in classical process it foresees inhibition of the process. However, proposed technology gives possibility to provide pure ammonia that may be realized in markets. So the main idea is that during anaerobic treatment, organic components that are waste are disposing, and biogas, and also with some amount of ammonia is generated. However, typically ammonia that's produced in this process goes to biogas, and the proposed technology foresees sorbing of this ammonia and by a liquid sorbent, and future its regeneration with producing of ammonia. Also, as the process is more efficient, the quality of anaerobic digestate is improved, and it gives possibility to realize it also in the market. Both those products will be analyzed on the possibility of realizing of the market. The proposed technologies also was highly evaluated before. There is a paper in Ammonia Energy Association that is well known worldwide, and it also includes the result of the technological papers that I talked in previous slide. So it is clear how ammonia could be used as fertilizer, but also there is possibility to receive energy. And to receive energy from ammonia, the ammonia fuel cells are used. Pure ammonia that received in the process that I noted before is used as source for anode in the fuel cells, and it provides release of energy that can be used for needs. And also the proposed technology provides a lot of options that could be implemented. One of the additional option is providing of monoammonium phosphate that also is in a pure form, so it could be used for nutrition addition for animals. Okay, let's analyze cost of ammonia, and now medium price is near to $1,000 per ton. However, it is forecasted that it will be decreased due to development of new methods like this one that I'm talking right now, and its price will be lower. Also, it is important to understand that general potential of produced ammonia in this way is really near to the amounts of ammonia that produced in countries. This situation is related also to Ukraine. The amount that could be produced using this technology is near to that amount that produced by using of typical chemical process of production of ammonia. And also the traditional process that names Haber-Bosch process, it requires much more conditions than the methods that we are proposing. So it should be much more attractive than traditional Haber-Bosch process. Taking into account this data, it is possible to calculate the potential of releasing of ammonia in the market, and also analyzing the amount of waste that is produced both in US and in EU. It is possible to analyze the potential of the market. From this graphic, it is important to say that the most waste is produced from poultry, and its amount much more than produced from pigs or cattle farms. So, taking into account the data that was noted before, the general potential for Europe and the USA separately is near to 11 billions per year, and for Ukraine is near to 0.11 billions per year. So this is pretty much, and this is sometimes even more than generated by traditional methods of traditional ammonia releasing of the market. In addition, it is important to provide complex approaches that include not only biogas and like ammonia using, but also fertilizer. If it wouldn't be used, it's also the problem for the environment. So it is important to provide complex approach that also foreseen using obtained fertilizer in the market. This market is comparably much more perspective. It's because of the huge amount of fertilizers that is generated. However, in EU, this potential is near to 263 billions per year, and also in Ukraine this is near to $10 billion per year. And also you can read detailing about the calculations about the technology in this paper, and also in the papers that published in East European Technology Journal. The link on this paper also, the reference on this paper also shown as reference in the paper. So thank you for attention. Here is my contact. If you have some questions, I will be glad to answer, and have a nice day.
Thank you for your presentation. Any question, colleagues?
I have a question.
Please.
Valery Zvarich, Institute of Electrodynamics. What forecasting method did you use in your research?
Please repeat the question.
What forecasting method did you use in your research?
Yes, there were no any forecasting methods that were used in my research. I just used the forecast that was provided by other companies, and there is a reference where I might take it.
You didn't do this research, okay?
Yeah.
Thank you.
We have a question in chat, I see. Explain what is the innovative method of obtaining ammonia from livestock waste and during anaerobic treatment?
Yeah, actually you can read more detail in our previous publication, but to be short, it foreseen using the organic waste, which contain a lot of nitrogen, and during anaerobic treatment, this nitrogen converts into ammonia that typically inhibits the process. Previously, we developed an approach to decrease the ammonia content in biogas reactor, and now we know how to use this ammonia that was taken out from this reactor, and it's sorbed by sorbent that located in reactor, and then this sorbent is regenerated with obtaining of pure ammonia that can be used as both as fertilizer and also as energy source.
Yes, thank you. And the second question from chat, have you compared your development with the extant analogies?
In the market there are a lot of analogs which foresees decreasing of ammonia content in the bioreactor, but there are no approaches that foreseen using this ammonia and provide pure ammonia. That's why this method is novel. And if we will compare this method with other methods that decrease ammonia content, for sure it will be more economically attractive because firstly, it provides obtaining of the additional products that can be sold in the market. Second, for example, there is a method that foreseen using of micromembranes to absorb this ammonia, and those micromembranes have their time of usage. So it's required to modernize the setting after some time. And in our case, the approach is fully not requires to have additional charges, just implement this sorbent inside the reactor and you can use it and regenerate.
Thank you for your answer. Dear colleagues, have you any question? Any comments, discussion? Okay. Let us going to the next presentation. Thank you for your presentation, dear Evgeny. And now we will see the presentation, some future of monitoring and diagnostic systems, technical condition of hydro units, taking into account smart grid technology. Valery Zvonich, I see here. Let's start.
Dear colleagues, my name is Valery Zvonich. I would like to present a report, some features of monitoring and diagnostic systems, technical status of hydro units. The report was prepared by researcher of the Institute of Electrodynamics of the National Academy of Science of Ukraine. Hydro units are used many variable modes, which leads to an increase in the load on all elements of hydro units. It can lead to unpredictable failure of their components and even failures in the operation of the hydroelectric power plant. Therefore, the use of diagnostic system is appropriate for solving such problems. The most promising non-decreasing diagnostic systems are vibration diagnostic systems. It is necessary to take into account that a significant number of hydrogenerators are low-speed machines with a low frequency of rotation of the hydrogenerator up to 150 RPM. Such features of the machine must be taken into account when choosing a diagnostic method. A significant part of the problems related to control and diagnostic of power equipment can be considered as problems of pattern recognition in the diagnostic space. Based on assessment and with knowledge of probable process, it is possible to make a remaining useful life prediction of the equipment and plan possible maintenance action based on the actual technical condition of the equipment. The main prerequisite for forecasting the remaining useful life prediction of the hydro units is the availability of information about the condition of the equipment or its components. To obtaining preliminary information, modern monitoring and diagnostic systems are equipped with smart sensors. Smart sensors provide the possibility of self-monitoring, which ensure obtaining data without abnormal values, which can be used without preprocessing to determine the state of the equipment or its units. The obtaining data are intended for use and as input data for analysis systems of means of diagnosis the technical condition of the component. The technical condition of the component depends on actual condition in which the generator operates. Actual conditions are determined with the help of additional sensors that are part of the smart sensor. As a rule, the assessment is performed by comparing the measure of the calculated states with the permissible value under which the correct operation of the equipment occurs. The structure of maintenance system, according to the actual technical condition of equipment, is represented on slide 2. To elaborate algorithm for the functioning of monitoring and diagnostic system, it's advisable to use autoregressive processes, which have become widely used during the implementation of mathematical models of information signals of various types and allow to elaborate algorithms for diagnostic technical objects that have a low frequency of shaft revolutions. The diagnostic methods is selected in the stage of evaluation of mathematical models. Usually, for example, vibration are modeled using mathematical models with continuous times. However, the majority of modern devices and information measuring systems in vibration diagnostics include microprocessors and microcomputers, and computers whose functioning algorithms are based on the digital methods of processing information system. Taking into account vibrations should be described using mathematical models with discrete types. We propose to use mathematical models of linear autoregressive processes. Linear autoregressive process is difference equation. Properties of the models are shown at slide 3. The kernel of linear autoregressive processes is recursively connected with autoregressive parameters. It is very important for development of algorithms of analysis of real data. One-dimensional characteristic function of linear autoregressive processes could be represented in Kolmogorov representation, one-dimension form, and the logarithm of one-dimensional characteristic function of all linear stationary autoregressive processes can be written in the form following. Autoregressive processes with periodic structures are also used. Such processes are the generating of the linear stationary autoregressive processes. The peculiarity of the given processes is the possibility of their use for the description of non-Gaussian periodic random signals. The properties of the processes are shown on slide 4. The processes has autoregressive parameters alternating in time with the same period is the main properties of the processes. A special experimental setup was developed at the Institute of Electrodynamics of the National Academy of Science of Ukraine. It was used for carry out practical research on vibration analysis of small machines, hydro units. The main goal of the research is to experimentally identify the connection between typical defects such as misalignment, eccentricity, lack of lubrication, damage of the outer and inner ring of the bearing as a result of metal painting, and the perimeter of diagnostic signs that clearly allow the defect to be detected. Experimental setup consists of 3 main units: electrical drive, massive shaft, and vibration measurement system of testing bearing. The 11 kilowatt motors ensure rotation of tested bearing at any speed in the range from 10 to 1,500 RPM. The main purpose of the bearing assembly and vibration measurement is the ability to artificially reproduce the main effects of the bearing and the placement of primary vibration transducing equipment. To measure the vibration acceleration of the bearing under the study was used, which made it possibility to measure the vibration of bearing in the frequency band 20 Hz to 30 kilohertz. As an example of bearing misalignment time defect was modeled. Educational groups were formed in the diagnostic space R sub 1, R sub 2, R sub 1, R sub 2 are the autoregressive parameters. Two-dimensional histogram corresponding to the selected test condition are shown in slide 6. The learning algorithms and evaluation of diagnostic signs is carried out. Then, on the basis of these populations, a vector of estimates of their mathematical expectation and estimates of variance and construction of covariance matrix of correlation between diagnostic parameters and the assessment of the characteristic of the distribution of diagnostic signs were built. If necessary, linear transformation of correlation matrix and normalization of correlation matrix are performed for construction, effect, and decision rules. The algorithm is more detailed presented on the slide 8. On the slide, formulas for estimation, expectation, variance, correlation matrix of diagnostic parameters are represented. A relation of linear transformation of correlation matrix of diagnostic features are also shown. The corresponding expressions for the likelihood radar are also presented. At the stage of planning our experiment, the threshold C and the required number of observations N are calculated. In the diagnostic mode, diagnostic sign assessed and a decision made on the technical condition of the diagnostic object based on the constructed solving rules. The proposed form of presentation of education aggregates is the relevant training blocks and the electric machine diagnosis system allow to organize the functioning of such system using SMART concept. Basic application and my email address are shown on slide 11. Thank you very much for your attention.
Дякую.
Thank you for your presentation. Dear colleagues, any question?
Can I?
Yes, please.
I have methodological questions for you. We use and construct autoregressive models using laboratory equipment. And the question is how you can spread the results of this model on the real hydro units, the bigger with different parameters and so on. How spread these results?
We have analyzed some hydro units blocks, for example, blocks Kiev hydro accumulation station. But now, unfortunately, this research is closed. But if we have some experimental results, not only hydro units, but another type of drivers, and other types of generators. The main methodology, main purpose of the models, it is a so-called constructive model of stochastic process. And when we applied this class of models after regressive process, we have possibility to estimate a kernel of autoregressive random, linear autoregressive random process. It's very important. It's very important for diagnostics. And now we develop the research, theoretical and practical.
Thank you.
Dear colleagues, any other question?
Can I ask?
Yes,
question,
Tali,
please?
welcome.
Concerning the field, natural field of your research, can you provide your experiments on small hydroelectric stations in the west of Ukraine, for example, Kryvyi Rih hydroelectric station? They have also turbines aggregates of 11 kilowatts, as I remember.
Unfortunately, no, we did not analyze, but it's quite prospective method for diagnosis of the class of machines.
Thank you, dear colleagues. Who have any question? We have chat for it, but according to the program, we must go to the next speech, and the next speech is on topic electricity consumption simulation using random coefficient periodic autoregression model. Mikhail Fris, I see here. And
Good afternoon, dear colleagues. Dear colleagues, my name is Mikhail Fris, and I'd like to represent the results of our research titled as Electricity Consumption Simulation using Random Coefficient Periodic Autoregressive Model. The outline represents the logic of our computer simulation model justification. That is, we start from the continuous time linear and conditional linear random processes, which are representations of electricity loads. We consider the cyclostationarity property. Then we introduce the discrete time conditional linear random process, which is the mathematical model of electricity consumption. And finally, at the particular case, we talk about random coefficient periodic autoregressive model, which is the main building block for our electricity consumption simulation model. The modern problems and challenges in the energy sector require comprehensive scientific applied research in the domain of energy informatics, which combines computer science, control systems, and power engineering in a single methodology. The contributions of energy informatics depends on adequate modeling and computer simulation of energy-relevant devices, systems, and related processes. It helps to train and validate new approaches, avoiding collecting big data sets. Simulation of electricity consumption can be also element of modern digital energy ecosystem. A continuous time conditional linear random process is defined as the stochastic integral from the random kernel driven by the continuous process with independent increments, where the random functions phi and eta are stochastically independent. It can be easily seen that if the kernel is non-random function, then the resultant model is linear random process, which is a very important mathematical model of electricity loads. If the process with independent increments is the Poisson with corresponding jumps, then the physically reasonable model of electricity load is represented as the sum of large amount of random impulses occurring at Poisson times, and there are examples of such kind of impulses recorded from the household appliances. And if that impulses are considered as the independent, then the resultant model is linear random process. But there are a lot of reasons to consider that impulses as stochastically dependent, and the corresponding model of electricity load as conditional linear random process. To take into account the cycle stationarity, we should consider the periodicity of corresponding probability characteristics of the investigated processes or signals, that is the cumulative distribution function or characteristic functions are periodic with respect to their time arguments with the same period t. Also, there is another useful mathematical model which is a periodically correlated random process when we take into account the periodicity only the first and second moment functions of investigated signal. The discrete time conditional linear random process as the mathematical model of electricity consumption can be obtained from continuous time process by using the aggregation during the corresponding time interval, and the discrete time conditional linear random process then is represented in the following form as the corresponding stochastic sum, which is formed by the kernel, which is the random matrix in this situation, and generating white noise. The most important particular case of the above defined mathematical model is a random coefficient autoregressive model, which is represented in the following form, and it is formed by the white noise again, and there are the coefficients which are random in this situation. And there are the following characteristics of this model, which are the variance of the generating white noise, the non-random parts of coefficients, and the covariance matrices of the random parts of the autoregressive coefficients. And as we already said before, we going to take into account the cyclostationarity properties of investigated processes. That is why we need to apply so-called random coefficient periodic autoregressive model. This is the kind of the above defined model when the characteristics are periodic with the same argument. And the mathematical model has been used in the structure of electricity consumption simulation, which is represented on this slide. And according to the main building blocks of this simulation model, first of all, we need to specify the period of the simulation, the number of cycles we need to simulate, the order of model. After that, we need to specify the corresponding characteristics of random coefficient periodic autoregressive models. We should emphasize that characteristics have to be specified as periodic functions, and they can be obtained from the statistical analysis of electricity consumption data. as the cyclostationary random sequence. Having that characteristic specified, we can then simulate the random part of coefficient, the cyclostationary white noise, then feed this white noise to the input of corresponding digital filter with random coefficients, and then adding the deterministic part, we obtain that our simulation of electricity consumption. The verification and validation stages cover checking the computer code for any programming errors, comparing simulated and real data visually, and using the statistical estimation and tests, etc. On this slide, we can see the example of simulation results. On the figure A, we can see the hourly electricity consumption of the enterprise belonging to the class of small and medium enterprise, and the figure B represents its computer simulation model. For the presented example, the mean absolute percentage error is equal to 15%. And if we talking about the further research intended to improve our simulation model, that we need to mention first of all the estimation and using the order of the model, using the non-normal distribution of generated white noise. We need to take into account the weakly cyclicity, and also we plan to utilize the higher order moments based or distribution based performance matrix for performance evaluation of our simulation model, and we plan to compare this model with our established simulation models. The conclusions are represented on this slide. Thank you for your attention.
Thank you for your presentation. I have one question. Can you detail the direction of the development of the proposed method?
Thank you for your question. First of all, I'd like to say that we didn't estimate the order of the proposed model. We just used the first or second order. That is why this is the direction of our next development of the model. Also, we need to take into consideration the weakly cyclicity of our simulation, and because generally the random coefficient autoregressive model is non-normally distributed, then we plan to consider the different distributions of the coefficients, and also we'd like to take into account the matrix that based on probability distributions to compare the performance of our model with another simulations.
Thank you very much. Any other question?
Yes, I have question.
Please.
Could you tell me a few words concerning of omega? As I have got your autoregressive model, autoregressive coefficient depend on omega.
Yes.
Is the area of definition L sub 1, L sub p, or what is it? Omega.
Omega is like the element of the sample space. If we define the probability space, omega is sample space, and because our coefficients are random, then we write the argument of omega.
And what space? L sub 1 or L sub p? Linear space or non-linear space?
Omega is the space of is the samples of the results of the experiments, and like the random process, it is, we consider it as the Hilbert in the element of Hilbert space. Yes,
Element of Hilbert space.
finite variance. Yes.
L sub 2.
Yes.
Thank you very much.
Dear colleagues, any other question?
Yes, I have one.
Welcome.
During many years before, traditionally, the scientists developed the stochastic model for describe the consumption process in energy systems. But now there are many new models based on neural networks, using neural networks. What can you say about stochastic model and compare with neural network one?
Yes, we did this comparison when we applied this model for the forecasting purposes, and we obtain the similar results. But just we need to take the same data, the similar data, to make the comparison. So to make to make the certain conclusions. So I didn't see the results when the computer when the neural network used for simulation of such kind of random process with periodicity.
It's also possible to use neural networks in order to take into account the periodicity, the stochastic of the process. I cannot see the difference between the possibility of the neural networks and the stochastic models.
Yes,
the both models is equal in this. And what is the difference between this?
But this time when we use the model of autoregressive with random coefficient, we can take into account the conditional heteroscedasticity of the investigated process, that is random conditional variance, which is an additional factor that can be used in the problem of forecasting for improvement of obtaining the interval forecast. So I don't know the methods related to neural networks that take into account the conditional heteroscedasticity.
Mm-hmm. Okay, and the next question is, what is the how long period you are predicted the consumption of electricity? What the duration of period? How long period?
So this time we're talking about simulation, and the period is 12 hours.
12 hours.
12 hours, excuse me, 24 hours. We're talking about hourly electricity consumption, 24
on the day ahead, yes?
No,
day ahead. Day ahead, or
when we talking about simulation, yeah, we can simulate on the specified number of periods.
No. I mean, no. My question is, when we increase the duration period for forecasting, for example, day, 2 days, a week, or bigger, it is more error, or it is more difficult to predict the consumption processes for a longer time. And my question is, what is period traditionally we used for forecasting, and guarantee that your model works good on this period?
Early, we were working with forecasting using these methods, and we considering the forecasting on 24 hours. We obtained the mean absolute percentage error. It's about 15–20% related to this data. But in this paper, we're talking about just the simulation, not forecasting, just computer simulation of data.
And what does it mean, computer simulation? What do you mean?
So we mean
what is the reality, and what is the simulation? What is the difference between reality and simulation?
We have the real data. We estimate the parameters of the model related to the given data, and then using our model, we can simulate that electricity consumption and use it for testing and other approaches, just in different regimes.
And what is
I must stop the discussion. I remind that we have chat for and possibility to ask questions there, but now we must go to the next presentation.
Thank you very much for your questions.
Thank you.
And the next presentation is atmospheric dispersion modeling and dose protection under the high uncertainty condition. I see the author, and let us start.
Good morning, good afternoon, and good evening, dear colleagues. My name is Yuri Krylenko. I work as researcher in State Scientific and Technical Center for Nuclear and Radiation Safety. I'm also a member of Emergency Center of Ukrainian Regulatory Body. Today, I would like to stress the issue of atmospheric dispersion modeling and dose projection under uncertainties associated with work time. So, a few words about my institution. Our center is a technical support organization of the State Nuclear Regulatory Inspectorate of Ukraine. Our main tasks include comprehensive technical and scientific support of the regulator in nuclear and radiation safety at all stages of nuclear facilities life. In the context of emergency preparedness and response, our organization is involved in the activities of the Emergency Center. Our experts participate in the development of regulatory framework, emergency planning, and monitoring activities. According to Ukrainian legislation, under the set of international conventions, the regulatory body of Ukraine is responsible for prompt notification about nuclear and radiological emergencies on the territory of Ukraine and beyond its boundaries in case of transboundary release. So SECC NRS is the supportive organization for Ukrainian regulator. It means in emergency phase, some our experts can be involved in response activity, providing calculation support to regulatory body. Let's have a look how philosophy of emergency preparedness and response is deformed in part of assessments. In peaceful time, the preparedness phase and the response phase are clearly separated by announcements of the event class. In wartime, there is no criteria for the transmission. For example, we found out about shelling of the Zaporizhzhia nuclear power plant and we start to respond, but the accident does not occur. And the situation gives up the opportunity and time to apply approaches that are more typical for the preparedness phase. There are using statistical assessments, preparation of additional source zones, application more precise assessment tools, and finally discussing our needs with the international community before the actual event happens. So since the full-scale invasion of Russian Federation on the territory of Ukraine, our experts provides analysis of potential accident may be occurred at Ukrainian facilities. The main task of radiological assessor in case of emergency is real-time assessment on recommended protective actions for the territory controlled by Ukrainian government, as well as for the territory temporarily occupied by Russian Federation. Obviously, in international practice, there has been no analysis of threats by the factor of military attack, impact of physical or psychological pressure on personnel, critical elements of destruction, impact of caliber and power of weapons, etc. Therefore, the list of reference events for the Zaporizhzhia nuclear power plant was based on previously studied scenarios, experts' opinion, and assumptions. This slide provides an example of only some of the scenarios. You can see 3 options for tail station blackout and 1 scenario for mechanical destruction of spent fuel cask at dry spent fuel storage at Zaporizhzhia nuclear power plant site. Since March 22, our emergency center has been activated several times. During the activation, calculations for Zaporizhzhia plant were provided in a regular basis. Using the air mass trajectory model, we can continuously monitor the nature of potential release spreading. And using European Decision Support System JRODOS, and other modeling tools for hypothetical event, we define the areas could be affected by evacuation, sheltering, iodine prophylaxis, and restriction on staying outdoors. This slide shows the results of modeling a hypothetical multi-unit event at Zaporizhzhia nuclear power plant, unit 5 and 6. In October 22, the presenter fields are the dose rate at the scale of the observation area. The results are provided just for demonstration. Okay. Over the past year, based on 1 year meteorological data, a number of statistical calculations were provided for the Zaporizhzhia nuclear power plant to define the distances and areas to apply protective actions. The assessments were performed for 3 reference systems as for July 22. Briefly speaking, we just run the model with 3 independent events at random time of during the day. As an example, this slide shows a probability map of the recommendation of iodine prophylaxis for children in case of a total station blackout of the operating Zaporizhzhia nuclear power plant unit as of July 22. And finally, I would like to list the challenges of assessment during wartime and some possible ways to success. Of course, one of the first tasks is very important. In a very short time, you need to find a safe working place. You can face a breakdown of information chains and communications with some experts of the emergency center, unavailability of the tools needed for the calculations in shelters. By the way, in the first time of innovations, some of our experts used just mobile and paper materials. Problems with electricity and internet connections, unreliability of data transmitted from capture facility. So how can we improve our response under wartime? We can organize a safe working place for the experts equipped with necessary tools, develop a secured visual platform for communication of the experts, create a library of the reference system for the expected range of threats for all possible facility conditions, use a secured server or cloud to transfer large files. A maximum diversification and independence of data transmission channels can also help here. We can use a mail messenger widget to save some information. And of course, regular training and exercise on calculation procedures in various conditions also can help here. To sum up, during the wartime, group of reference events can be considered based on expert view, current situation, and possible character of impact. Preparedness to an emergency resulting from the military attacks requires more information about the potential military threats and facility response to a spectrum of hostilities. It's possible to come up with mechanism for prompt recalculation of emergency planning zones and provide an additional resources to mitigate the radiological consequences, considering the current situation and public behavior under war conditions. Development of a secured virtual platform for communication of the emergency center experts can be the optimal solution to support emergency preparedness and response system under wartime. Thank you for your attention.
Thank you for your presentation. Any question, please?
Can I ask
Sure,
one
question,
small
Will.
Please, Vitaly.
A short question. What is the main attack scenario with a nuclear release for Zaporizhzhia nuclear plant?
I see. Yes, and thanks for your question. It's an interesting question. In peaceful time, you know, we have a risk analysis to provide a list of potential events at nuclear power plant. But in wartime, we had some repeated total station blackout during last year. So we consider the main scenario total station blackout. Also, we have several source terms for mechanical destruction of the spent fuel dry cask at the spent fuel storage. So this is two main, I think, scenario that considered for wartime. And now, as Zaporizhzhia nuclear power plants, we have almost the same case when we have a station blackout. I think from yesterday, you know, and this is a typical threat under war time. Thank you.
Thank you, dear colleagues.
I have a question.
I have.
Yes, Sergey Ivановich, please.
Sergey, please.
talking about the necessity of information the society living around the nuclear power plant about the dangers, it is very important to forecast the spread of radiation and working with model very accurate. And what can you say about the adequacy of your forecast model?
Oh, it's not a question. You know, this all model just a model. Of course, in real case, we will have a monitoring data. So we are really waiting for the monitoring data. But some countermeasures like a sheltering to shelter public or iodine prophylaxis can be provided before the huge release. So for this case, many countries use just model. I know that Japan, after Fukushima, just put away the modeling. They do some action only after first measurement. Yes, so this country do not rely on the model, but in most countries of Europe, United States use this modeling. I can't really say about the accuracy of this modeling because we provide some kind of benchmarking in our activity with different countries just to compare our results, and we compare the results on the past events, and I should say that nice results in convergence. This is one order. So one order it's nice. Just for modeling, just for forecasting, this is quite acceptable. Quite acceptable error in modeling.
Can I have one more question?
Yes, please.
What a government decision must be taken in order to introduce this procedure of modeling and spread of information for the society about the danger of the exploration of nuclear power plants? What decision must be taken from the government?
From the government, we have the SNS. We have some emergency service of Ukraine to provide countermeasures. From side of government, our organization provide press release. It's quite important things to avoid non-radiological effects such as anxiety and not validated information from Telegram channels, etc. So government support the public using press releases and communication with IAEA, International Agency on Atomic Energy. So yes, so today I should say that we have standard procedure to communicate with public, and it seems that public have some trust, have some that public believe to the government now. Just think in compare to Soviet Union time.
Mm-hmm.
Yes.
Thank you.
Thank you. Thank you.
One short question.
Please.
Did you use resilience method for analysis of your quite dangerous incident, because the method has possibility to estimate recovery time for the area.
Yeah, I see question. And thank you for the question, nice question. We use, we provide the modeling just for urgent countermeasure. It's evacuation, iodine prophylaxis, and sheltering. You are talking about late phases, I said yes, and for this type of modeling, this is some kind of another type of modeling. So in our emergency center, we just deal with the early phase of the accident. After that, some different tools can be applied to forecast, to make a forecast for 10, 20 years or 50 years. So yes, it's just another type of modeling.
Thank you very much.
Dear colleagues, a very interesting discussion, but according to the program, we must move on. Thank you, Yuri, for presentation, and all colleagues for questions.
Thank you.
The next presentation is on topic short-term forecasting of electricity imbalance using artificial neural networks. I see authors, and let us start.
Hello everyone, my name is Victoria. I present a report on the topic short-term forecasting of electricity imbalances using artificial neural networks. Today, one of the important factors affecting the reliability and efficiency of the integrated power system of Ukraine is the instability of electricity imbalances, which has been observed since the implementation of the new model of the wholesale electricity market. Access to prior information on electricity imbalances allows the transmission system operator to improve the accuracy of creating the energy system operating mode. It also enables optimizing the balancing market and ancillary services market operations, thus increasing the reliability of the IPS of Ukraine functioning. The market participants, including power companies, to determine their participation strategies in different market segments to reduce the cost of electricity. Reducing the cost of imbalances for electricity suppliers, which has a positive impact on the retail electricity market and the prices of end consumers. The purpose of this research is increasing the accuracy of forecasting electricity imbalances using neural network models. To achieve this purpose, the following tasks were set and implemented. Analysis of two types of neural networks with recurrent levels LSTM and LSNet. Comparison of the obtained results of short-term forecasting of daily schedules of electricity imbalances using LSTM and LSNet neural networks with the forecasting results obtained using the vector autoregression model VARMA. Two types of neural networks with recurrent LSTM layers and LSNet were built to predict electricity imbalances. For comparison, the VARMA model was used, which showed the best results among autoregression models in the past. Overall data included hourly volumes of positive and negative imbalances of the IPS of Ukraine for the period from July 2020 to July 2021. Training test split is 90/10%. The input vector includes four previous values. The forecasting horizon is 1 hour. The number of training epochs is 5,000. The best prediction results were achieved with 20 hidden large neurons. Data obtained from the official website of the national energy company Ukrenergo. The test sample for comparison is 36 days and test day is 20th of July 2021. On this slide you may see the MAPE and RMSE forecasting error charts. The most accurate forecasting results of both positive and negative electricity imbalances were obtained using the LSTM model. The results obtained with the LSNet model are much worse, by 50% compared to the other model for positive imbalances and by 47 and 66% compared to Varma and LSNet respectively for negative imbalances. On this slide you can see daily graphs of MAPE values for positive and negative electricity imbalances. The graphs of daily MAPE for LSTM results have less pronounced local extrema, which indicates the preservation of the trend throughout the entire range on the test sample. It does greater stability of forecasting results. In particular, the LSNet model performs much worse in forecasting negative imbalances than positive ones. On this slide you can see daily graph of RMSE values for positive and negative electricity imbalances. Here we have the same conclusions as from the previous figures. On this slide you can see graphs of electricity imbalances values predicted using built models compared with actual values for 20th of July 2021. The graphs shows how the curve of values predicted by LSTM repeats the shape of the curve of actual values, unlike the curves obtained using other models. Conclusions. The use of artificial neural networks made it possible to reduce the error of forecasting total electricity imbalances for different testing periods. LSTM shows the lowest values of MAPE forecasting error. For positive imbalances, the daily forecast error is 21%, while of Varma model the error is 41% and LSNet is 47%. When forecasting negative imbalances, LSTM also has the lowest error value of 9% compared to Varma 17% and LSNet of 67%. The forecast of the entire date sample has significantly larger errors, especially of the date of positive electricity imbalances. LSTM 66, Varma 34, LSNet 53%. Therefore, the smallest error of forecasting results is achieved using an artificial neural networks based on LSTM. In this way, the LSTM is the most effective method for imbalances forecasting in terms of flexibility and ability to model multivariate data, which essentially increases the effectiveness of forecasts. The results of the conducted research prove the success of the proposed forecasting models and indicate the need to their further development, taking into account additional factors. Thank you for attention.
For your presentation. Any question? Please, short question.
Yes.
Welcome.
Did you define your vector autoregressive processes, because I have not any formula in your presentation. Is if you consider processes with vector of generating processes, is you consider processes with vector matrix of coefficient or something else? Definition of the processes.
Mhm. Thank you for your question, but I'm very sorry. I can't answer on this question now. Sorry.
Thank you very much.
I have a one short question. What can you tell you about the factors that will be taken into account in your future development? Maybe, for example, a renewable generation.
Yes, in the future, in this model, will consideration of additional factors, for example, yes, renewable generation forecast.
Okay. Thank you for your presentation, but we must move on. And the next presentation is SWOT analysis of electric transport and V2G implementation for power system sustainable development in the term of Ukraine. I see author and start now.
Hello, dear colleagues. Thank you for being here. My name is Ganna Kostenko. I'm a junior researcher from General Energy Institute of National Academy of Sciences of Ukraine. Today, I will present the results of our research on SWOT analysis of electric transport and vehicle-to-grid implementation for power system sustainable development in the terms of Ukraine. The electrification of transportation is considered a key requirement for the Paris Agreement implementation. As part of this effort, there is a gradual replacement of internal combustion engine vehicles with electric vehicles worldwide, including Europe and Ukraine as well. Over 100 countries, including Ukraine, have joined program for electric vehicle development. This transition aims to reduce carbon dioxide emissions. The decrease in cost of battery technology, along with increased battery capacity and driving range, has contributed to the steady growth of electric vehicles. This growth will inevitably put strain on the electric grid. Therefore, the widespread adoption of electric vehicles and the development of charging infrastructure should occur in a synchronized and coordinated manner with the transformation of power system. According to the International Energy Agency, the global electric vehicles fleet surpassed 10 million units in 2020. By 2030, it is projected to reach 150 million units, and by 2040, 300 million units. Over the past 10 years, significant progress has been observed in the adoption of electric vehicles in Ukraine. According to statistical data, in the beginning of 2023, there were almost 47,000 registered electric vehicles in Ukraine, with more than 13,000 being registered during last year. The Nissan Leaf remains the most popular model in Ukraine, with nearly 40% share of the electric vehicle market. The Ministry of Infrastructure of Ukraine has presented the transport strategy, which aims to have at least 250,000 electric vehicles in Ukraine by 2030, with municipal buses and taxis being fully electric. With the increasing share of electric vehicles, the demand for electricity required for battery charging will significantly increase. This may result in uneven electricity load due to the rise in evening peak demand and put additional strain on the distribution infrastructure. Integrating electric transportation into the existing power system requires careful planning and optimization. This study aims to analyze the opportunities and threats for the development of electric transportation in Ukraine, as well as to examine its interaction with the power system. State support policy in Ukraine. The experience of many countries such as Norway, Netherlands, Germany and others shows that government support policies, incentives and benefits can significantly accelerate the adoption of electric transportation. In 2022, 2 laws were adopted in Ukraine to stimulate the development of the electric transportation industry. The joint project between Energoatom and Ukrgazbank was initiated to create a national network of fast charging stations. And finally, in October of 2022, the concept of the smart grid implementations in Ukraine until 2035 was approved. It includes several tasks directly related to electric transportation. The process of charging an electric vehicle serves as a point of interaction between the transport and power sectors. It includes charging infrastructure, charging strategies, and auxiliary services to the power system that arise from the application of certain strategies and technologies. Charging infrastructure in Ukraine. One of the necessary conditions for the growth of electric vehicles is the development of the charging infrastructure. 70% of private electric vehicles prefer home or workplace parking charging. In Ukraine, in the beginning of 2022, there were almost 7,800 charging points, of which 76% were slow charging with alternating current and 24% were medium or fast charging with direct current to the battery. Usually, charging infrastructure is assessed by the number of electric vehicles per public charging point. In Ukraine, this indicator was 4.3 per electric vehicle, while the average in Europe was 6.8. About vehicle-to-grid concept. With the widespread adoption of electric vehicles, significant amounts of electrical energy can be stored in their batteries. According to research, private electric vehicles are not in use for the majority of the day. Nearly 90% of time it is staying parked. It is practical and feasible to return the accumulated electrical energy in their batteries back to the grid and utilize it to balance the load curve without compromising the primary transportation function of the electric vehicles. This slide presents the vehicle-to-grid concept both in terms of individual vehicle participation and through an aggregator, which can be more efficient and beneficial for everyone. However, to achieve this, it is necessary to regulate the rules for aggregator participation in electricity markets. Vehicle-to-grid enables several beneficial tasks to be performed: frequency regulation, peak load reduction, consumer benefits, and energy reserve. About battery degradation. This slide depicts the dynamics of battery capacity degradation. Usually, manufacturers provide an 8-year warranty, and as shown, the battery capacity decreases by 35% over 8 years of vehicle usage. The majority of electric vehicles in Ukraine, around 90%, are used and approximately 5-6 years old. Battery degradation reduces the driving range of the electric vehicles, increases charging time, and diminishes the overall battery performance. Battery degradation is influenced by the age of the electric vehicle, temperature conditions, especially high temperature, operation at high, about 80%, and low, about 20% charge levels, as well as frequent use of fast charging stations. Based on the research material, we have conducted an analysis of the internal and external factors that determine the development of electric transportation and vehicle-to-grid implementation in Ukraine. For this purpose, the SWOT analysis was used. This slide presents the internal factors, such as strengths and weaknesses. Among the strengths can be highlighted environmental friendliness, reduction of air pollution, especially in big cities, sustainable growth of the electric car fleet in Ukraine, electricity is much cheaper than fuel, favorable climate conditions, high share of private car ownership, and others. Among weaknesses can be highlighted high price for new electric vehicles and high price for replacing batteries. Low share of electric vehicles in the country's car fleet. 90% of electric vehicles are used with partially degraded batteries. The need for daily charging, the need to determine the time and place for charging. Lack of own production of electric vehicles, batteries, and vehicle-to-grid devices in Ukraine, and others. This slide presents the external factors that contribute to the development of electric transportation in Ukraine, such as opportunities and threats. Among the opportunities can be highlighted reducing of carbon dioxide emission, reducing of use of natural gas and petroleum products, and dependence on energy import. Implementation and development of smart grids. The growing popularity of electric vehicles. Possibility of using of electric transport as a consumer regulator of electric load, and as a distributed storage of electricity. Use of battery of electric vehicles as a power reserve in emergency situation in the power system, and others. Among the threats can be highlighted probable rising of electricity prices, outflow of young solvent population due to war or economic reasons, large secondary market for more affordable cars with internal combustion engines, Charging electric vehicles directly depends on human activity and increases the evening peak of electricity consumption. Uncontrolled charging causes a number of negative effects in the power system, grid stability and electricity quality, and others. This slide presents the significance of charging strategies and their impact on the daily load curve. The red line represents uncontrolled charging, also known as charging by demand, with a characteristic evening peak. The blue line represents managed charging using tariffs or unidirectional smart charging, vehicle one grid, which dynamically adjusts the charging time and speed based on tariffs and grid loads through sensors and controllers. The green line represents bidirectional intelligent charging, vehicle to grid, which not only charges the electric vehicle but also returns electricity to the grid during periods of energy shortage to support peak power. The impact of charging strategies modeled for Belgium. Belgium's electric load graphs clearly shows the regulatory capacity of electric vehicles with smart grid concepts. The impact of vehicle one grid and vehicle two grid smart charging on the electric load schedules represented on this slide, which shows the simulated average daily electric load from EV charging in Belgium for 2030. It can be concluded that in Ukraine, vehicle-to-grid technology is still in its early stages, with a limited number of pilot projects. However, the potential benefits of vehicle-to-grid in Ukraine are significant, including the ability to reduce energy costs, improve grid stability and reliability, and support the integration of renewable energy sources. To fully realize the potential of vehicle-to-grid in Ukraine, there are several challenges that must be overcome. These challenges include a lack of infrastructure and investment, regulatory barriers, and the need for more research and development to optimize the technology. Overall, while there are significant challenges to overcome, the potential benefits of vehicle-to-grid in Ukraine are substantial, and efforts to develop smart technologies should continue to be one of the priorities for power sector. For more detailed information about the subject, I suggest you to get acquainted with our papers. Thank you for attention.
I have one short question. Is this V2G technology economically available for Ukrainian consumers?
The use of this technology requires additional costs from consumers. The device itself costs $500–700 additionally. But new EVs, electric vehicles, are equipped with built-in device. But since in Ukraine electric vehicles are mainly used, it is necessary to invest additional funds in order to use it.
Thank you very much. Any question? But please, short. Yes, Vitaly, you are welcome.
Thank you. A very short question about what can stimulate consumer to discharge his car. Is it money or social responsibility? What is it?
Only money. It only must be economically beneficial for them.
Thank you.
It's only the system of tariff, system of political regulations, and others.
Thank you, dear colleagues. But we must move on. And the next presentation is high quality education for better sustainability and resiliency. I see the author, and let us start.
Dear colleague, have a good day. I am Mark Prazan. Together with Victoria Prihodko, we are conducting research, and here we'll share with you high quality education for better sustainability and resilience. This is a general structure connected with our workshop, general context, situation in Ukraine, with similar project problems and possible solutions, the role of academia and universities, and further development considering possible risks. As you know, our workshop connected with some subject. Some of them you could see here. That is quite complex and uneasy task. It's worth doing and a lot of research. Together with that, situation is much more complex and complicated because of huge transformation in the world. We have a poly crisis in energy sector, climate change, and clash of nations that led to the uneasy situation with supply chains. Wind and solar we could get for free, but not raw materials. Not raw materials, not finance, and stability in supply chain. As you know, it takes $250 billion according to estimation given by EBRD currently. We know much bigger numbers. We will face this challenge after our victory. Said that, we have to understand that the situation is not easy with big project connected with critical infrastructure or something others. Ben Flyberg with his colleagues has shown that in database of 16,000 projects, only 0.5% of total number has been done in time, under the budget, and according to expected profits. The second point is human capital. The situation in Ukraine is not easy because of about 8 million people leave the country, hopefully for a while, and they will come back. But fact is, now they are not in Ukraine, and more decremental research has shown that about 7 million male we have in the age from 18 till 16. They are fighting in our army. They will be engaged in rebuilding, in the supporting economics, but maybe this number is not sufficient. In the wake of previous problem, we could find some solutions. Key point is education. The second, internationalization of connection with research and development centers, think tanks, like DARPA in US, in Canada, program Horizon, and provide education based on EdTech platform. We provide study about 150 education EdTech platform in the best institutions.
For technology adoption and automation to create productivity growth in Europe, there are three main prognosis via the education system and the governments have a role to play. First, reskilling and upskilling human capital on the people already in their working lives, more than 50% on the total number. Second, tens of millions and new jobs. Third, automatization will drop by over 50 millions by 2030. There will be a critical need to create unique and teach different jobs. Most jobs requiring green skills represent annual growth with 8-20%. Competences and skills involve changes in training objectives, and the expanded training results as companies necessary from implementing professional tasks such as hard and soft skill, understanding taxonomy and stakeholder relations. The balance between theory and practice is essential. Thus, change is society in different domains create requests for the modernization of education. But the peculiarity is that learning process is about 4 or 5 years, and the demand can be more.
To ensure sustainability and resiliency of energy system, we need to obtain access to the maturity technology, finance, and policy, and relevant legislation. Say that we need to understand about risk, because technology could be mature, but could be in process, maturing, so-called maturing, or immature. For middle or low income countries, much better to rely on mature technologies. Access to finance. Global economy needs to get trillions $, and with financial mechanism, access to capital provides the same job we need to do in Ukraine. And with regard to legislation, policy, government regulation, standardization is quite serious subject to follow. The next slide is about further development. As you know, the ESG reporting and disclosure will become mandatory since 2024. It means that each company or institution will have sustainability departments, CSO, and others. This direction will be connected with technological requirement level, and we should consider it holistically plus finance. Thank you. If you have question, I will happy to answer. We will happy to answer.
Thank you for your presentation, dear colleagues. Any question? Vitaly, you are welcome.
Can I ask a question? Hello, Mikhail. Nice to see you. What do you think? How crucial is this transfer from hard skills to this, from the importance of hard skills to importance of soft skills for today's education and its results?
Oh, no, that's an interesting question. Actually, I didn't. I omitted mentioned about soft skills on the slides, but in order to keep focusing on the specific points, in situation when technology are developing, artificial intelligence and so on, role of soft skills will be increased. Will be empathy, creativity, lateral thinking, and so on. It's maybe one of the key skills we need to teach and to learn. Number one point. The second point about hard skill, advanced technology quite soon will kill a lot of jobs and a lot of specialization, because they could be much better in hard skill, but some skills will be still required, And as we see, according to World Economic Forum data, yes, and McKinsey data, wind turbine, solars, multi-disciplinary skills with connected with ECG reporting and so on, this job will be increasing. And my personal opinion is I put on the first place, by the way, soft skills, then hard skills.
Thank you.
Any other question, please? Any comments, discussion? Thank you, Mikhail, for his presentation. And now we have a possibility lunch break, and I'd be glad to see all of us in 30:45. Let's go to break.
Thank you.
Thank you.
Dear colleagues, I hope that everyone has recovered their strength and is ready for the next 16 interesting presentation. According to our program, the next presentation is on the topic on the potential of Ukrainian higher education establishment to satisfy the demand in personnel for renewable energy development. I see the author and we start the presentation.
Dear colleagues, with this presentation, we would like to highlight the main findings of research conducted on the potential of Ukrainian higher educational establishments to satisfy the demand in personnel for renewable energy development. The study has been carried out at the Cherkasy State Technological University by Oksana Zakharova and Lyudmila Usek. And today the speaker is Lyudmila Usek. The research aimed to analyze if the Ukrainian higher educational establishments are prepared to satisfy the predicted demand in personnel needed to ensure sustainable development of the renewable energy market. The study addressed three issues. First, we analyzed the contingent of students majoring in electric power engineering, electrical engineering, and electromechanics, who are studying educational programs in renewable energy. Based on the qualitative data and the experience of realizing educational programs in renewable energy, we have formulated the markers of an educational program's success. Finally, based on the above, we attempted to devise recommendations for increasing the number of highly qualified specialists in renewable energy on the Ukrainian labor market in the post-war period. Based on the vast literature highlighting various aspects of renewable energy development globally, as well as Ukraine's experience in this field, we can formulate two basic conditions that are able to ensure sustainable growth in renewable energy. The first condition is to actively deploy technical means and innovative engineering solutions to develop renewable energy in Ukraine. And the second indispensable condition is regular personal supply. And here an effort is required of Ukraine because Ukraine has to provide for this condition independently and autonomously. The statistical data for the research were obtained from the sources that are mentioned on this slide and which are represented mainly by governmental websites and electronic databases. To start with, in this section, I would like to briefly discuss the background of renewable energy development in Ukraine in terms of the legislation and its history. The idea of strengthening the role of renewable energy in the Ukrainian economy has been around for the past 2 decades and was not inspired by the war or the blackouts. In the Ukrainian legislation, the first normative documents highlighting the development of renewable energy date back to 2009, as we can see in this slide. In October 2014, the Cabinet of Ministers of Ukraine approved the National Renewable Energy Action Plan for the period until 2020. The full text of our article contains several comments on the document and its today's relevancy. In December 2017, Ukraine joined the Charter and in February 2018 became a full member of the International Renewable Energy Agency. Participation in this association enabled Ukraine to access the world-class experience and knowledge in developing and implementing technologies for utilizing renewable energy. In the years preceding the war, the share of renewable energy in the structure of domestic production in Ukraine fluctuated within the range of 7 to 10%. These data imply that it has not yet been possible to fully utilize the potential of renewable energy. One of the reasons is the failure to provide the industry with highly qualified personnel. And it is worth mentioning that the national plan did not pay due attention to this issue. At the moment, training specialists capable of being directly engaged at renewable energy facilities in Ukraine is being delivered within two specialties: 141 power engineering, electrical engineering and electromechanics, and 145 hydropower. This slide presents the territorial distribution of educational institutions training students in specialties related to energy. The largest number of educational institutions are concentrated in the Ukrainian cities of Kharkiv, Kyiv, and Dnipro, which is natural and predictable since these cities represent highly developed industrial regions. In the next part of my presentation, I would like to mention some qualitative data that we have obtained, because these data have some significance in terms of the issues we are studying here. So first, I would like to comment on the numbers of students majoring in electric power engineering, electrical engineering, and electromechanics. At bachelor's level, as you can see, slightly less than 400 students in total are enrolled on all the accredited educational programs in all the 4 years of study. And in the slide, you can see the 4 universities preparing the highest numbers of students. An implication of this finding is that qualified graduated bachelors will replenish the labor market gradually and will not immediately enable intensive development of the renewable energy sector. In addition, some of these students will continue their studies at graduate programs and will enter the labor market in another 1.5 or even 2 years. At the master's educational level, as we can see, 91 students is enrolled. If these students do not choose to continue their studies at any of the postgraduate schools, they will enter the Ukrainian labor market in January, February 2024 or 2025. One more specialty that we have mentioned today is hydropower. And here we can see that only 3 Ukrainian universities train specialists in hydropower at undergraduate and graduate levels. These statistical data suggest that Ukrainian higher education institutions possess enough potential to prepare about 500 graduates in 2 renewable energy specialties by 2026. This number may satisfy the need to neutralize the processes related to staff turnover at the existing facilities. However, ensuring the expected increase in the share of renewable energy in Ukraine is unlikely to be achieved with these numbers of graduates. The evidence received by analyzing the most successful educational programs enabled us to formulate the markers that measure the performance and quality, or in more simple words, they measure how successful the educational program is. So marker number 1, highly professional teaching staff involved in delivering the educational program. Their high scientific potential and practical workplace experience in the field of renewable energy, and their command of foreign languages is also important. Marker number 2, providing the educational process for the educational programs with modern certified laboratories with high-tech equipment. A positive example here is Cherkasy State Technological University, and more details you can find in our article. Marker number 3, close cooperation and the availability of double degree programs with the universities abroad. Marker number 4, introducing a practice-oriented approach to education. This can be illustrated by a positive example of Lviv Polytechnic National University, and again, you can find more details in our article. Marker number 5, possibilities to offering the students the possibilities to participate in international academic mobility programs. The mobility may take 1 or 2 semesters. Replication or targeting these markers will significantly enhance the existing educational programs in renewable energy. And these markers may also define the quality standards for new educational programs that are going to be opened in renewable energy. In summary, the results of this research show that the current numbers of specialists trained in renewable energy will not facilitate intensive development of renewable energy announced by the Ukrainian government. Thus, we would like to offer several directions that, taken together, will form a strategy to reach higher numbers of highly qualified specialists in renewable energy in the Ukrainian labor market in the post-war period. So, number one, increasing the level of remuneration in the renewable energy sector in Ukraine will enhance this sector. Recommendation number two, ensuring more investment into the development of human capital, satisfactory working conditions, and sufficient social package at renewable energy enterprises in Ukraine. Special attention should be paid to the social protection of young professionals and the development of their talents. The next recommendation concerns professional development and retraining. Expanding opportunities for professional development and retraining for specialists from the primary and secondary labor markets will also enhance the development of renewable energy market. The next recommendation. This is enhancing the current educational programs to satisfy accreditation requirements. In this context, it is important to focus on the best practices of the world's leading universities. The next recommendation is enriching the existing curricula with the disciplines that acquaint students with the leading global experience in the field of renewable energy, the basics of international energy standards, and sustainable development management. One more recommendation is for those universities which train exclusively bachelors or exclusively masters in renewable energy. So it would be advisable to launch educational programs at another educational level as well. The next strategy is launching new educational programs in renewable energy at both undergraduate and graduate levels. Next, increasing the professional and qualification level of lecturers and teachers participating in delivering renewable energy educational programs. The next strategy or direction is increasing the prestige of the entire spectrum of professions related to renewable energy. And to recap my presentation, I would like to mention that implementing the above measures will fetch significant social, economic, and ecological effect. We are thankful for your attention and will welcome your questions now. Thank you, dear colleagues.
Thank you for your presentation. Dear colleagues, have you any question?
Can I?
Yes, welcome.
In your conclusions, you formulate recommendations, but the short questions, for what?
Thank you for your question. We approached this problem from this issue from managerial and humanitarian point of view. And the basic point that we tried to make in our presentation was that the documents and strategies we have analyzed before, they could not reach there and could not realize all the aims and all the objectives that they set. And we found out that the reason for that was insufficient supply of proper specialists in the labor market. So these recommendations would be useful for, first of all, university management, how to develop and how to increase the numbers of properly prepared specialists to satisfy the labor market and to enable these aims objectives to be realized. Of course, these recommendations, well, we would like to see that, but who knows, could be used by the Ministry of Education to probably maybe develop some more recommendations or foresee the corresponding directions in their policy. And well, of course, these recommendations can also be used by department heads to see what they can do in their departments and at their universities. Does that answer your question?
Thank you. Any other question, please? There are no questions, I see. So thank you, Arthur, for very interesting presentation, and move on to the next speech. Determination of components for head storage material. I see authors, and we can start.
Good morning, dear colleagues. The report of determination of components for heat storage material is brought to your attention. The reporter is a leading researcher of the Institute of Engineering Thermophysics of NASA Ukraine. Today, the world is moving to the fourth and fifth generation district heating system of heating networks, the main elements of which of the thermal energy storage. One of the energy systems.
Excuse me, we can see the presentation.
That has become wise.
There are no slides.
No slide?
We didn't see presentation.
Oh.
No slides, a very low volume.
Excuse me.
Sound yes, but video absent.
And sound is too low level.
Good morning, dear colleagues.
It's okay.
The reported determination of components for heat storage material is brought to your attention. The reporter is a leading researcher of the Institute of Engineering Thermophysics of NASA of Ukraine. Today, the world is moving to the fourth and fifth generation district heating system of heating networks, the main elements of which of the thermal energy storage. One of the energy storage system that has become widespread in recent years is the mobile thermal energy storage that has tanks filled with heat storage material. Therefore, especial attention is paid to the search of new types of coolant, heat accumulating materials, and research of their properties and determination of rational operating parameters. Specially created heat storage materials are often used. They work under the necessary technological conditions and meet the strict requirements for the safe transport of liquids. In 2020, a mobile thermal energy storage was created and tested for 3 heating seasons. In the period of 2022-23, it was used at the territory of the Rehabilitation Center of the Ministry of Internal Affairs of Ukraine. Mobile thermal energy storage consists of an accumulation section and a hydraulic section. 8 storage tanks of the capacity type are installed in the storage section. The design of each battery tank has 2 spaces. First tank is filled with the heat storage material. Second tank is filled with fast change materials. Experimental research, a test bench heat storage of capacity type was created. The tank consists of tank 1, which is filled with the heat storage material under investigation. The tank 2 contains phase change material which was selected in advance experimentally. The heat storage material is heated by an electrical heater 3. Temperature measurement is carried out with the thermocouples 4, which work together with the microprocessor module Triton 5. Samples of heat storage material under investigation placed in the tank 1. For creation the thermoaccumulating liquids in our experiments, we used carbomethyl cellulose, xanthan, and guar gum. These components are represented in this slide. After completing the research, an application for Ukrainian patent was submitted. The slide shows the order for conducting experiments. Each number of the experiment corresponds to a different chemical composition of the heat storage material. When analyzing the obtained experimental results in the following graphic figures, this correspondence is preserved. Maximum energy consumption per cycle was recorded in experiment number 1, where water heat of fast change materials, PCM. The lowest energy consumption per cycle was observed in experiment number 10, where the heat storage material includes antifreeze and xanthan gum in the amount of 1%. The difference between these experiments is 27.3%, which is a significant difference for the average consumer and acceptable for industry. Unacceptable for industry. The experimental period includes heating and cooling time, which is equal to 1 cycle. It can be seen in figure that the shortest cycle period was in experiment number 1, where the water heated the PCM. This fact can be explained by the abnormally high specific heat capacity of water compared to any other liquids. In experiment number 2, water was replaced with a heat storage material made of water at antifreeze, which increased by the cycle by 15%. But the longest cycle time is in experiment number 7, which is 24 longer than experiment number 1, which indicates an extended period of accumulation due to the addition of 1% guar gum. The ratio of the spent energy to the period of the heating-cooling cycle allows to assess the efficiency of the heat storage material. Therefore, experiment number 1 is the least effective as it requires a significant supply of energy with a minimum accumulation time. Experiment number 10 is the most effective as it has a lowest value of the ratio. In general, it is 34.8%. That is, when conducted diffuse research, xanthan gum is one of the priority components. The PCM sample, fast change material sample, in this case cyarazine, was filled into tank 2 and was not changed throughout the entire cycle of experiments from experiment number 1 to experiment number 10. Mass measurements were carried out before and after thermal cycling. Some samples were weighted electronic balance with automatic calibration. The initial mass before number 1 was 107.5 gram, and after the last experiment 10, the mass was 106.2 gram. This means that in the process of 40 thermocycling heating cooling, the mass changed within 1–2%, and this material can be used to fill the thermal core of mobile thermal energy storage. As a result of the conducted experimental studies, the expediency of using the water, antifreeze, xanthan gum, and guar gum as part of the heat storage material was established. Determining the concentration of these substances will be the subject of future research. The safety of using cerazine in the thermal core was also confirmed by studying in the change in mass before and after thermal cycling. Thank you for your attention.
Thank you for your presentation. Dear colleagues, any question, please? So I have one short question. How many examples of using this technology are present in Ukraine today?
This investigation. This investigation, the time is carry out. We have stuff composition this material, and we patent.
We submitted an application for patent, and our research showed that it's not widespread in Ukraine, these substances as coolant and heat storage material.
Thank you so much.
It's new substances for this topic in this sphere.
Okay, dear colleagues, any other question? So one short question: what is the future research? Do you think in this case?
We have another research is concentration. This
we are going to choose a proper concentrations of these substances in order that they are safe to use in industry. Because now it's just an experimental research in test bench.
Yes, but we used these materials in thermal energy storage. We have mobile thermal energy storage. This instrument in two periods.
Heating
seasons, and worked and heated
and we use it in the Institute of Thermophysics, this heat storage, thermal energy storage.
Thank you very much, dear colleagues. Any other question? Comments, discussion? I don't see any. Thank you, authors, for the interesting presentation, and move on to the next presentation. MILP formulation of the UC problem with boundary condition of the autonomous forecasting horizon IC author, and we can start.
Dear ladies and gentlemen, first of all, I thank the organizers of the conference for the opportunity to present a scientific report, Mixed Integer Linear Programming Formulation of the Unit Commitment Problem with Boundary Conditions on the Autonomous Forecasting Horizon. My name is Sergei Savov. I am Doctor of Technical Sciences, Professor, corresponding member of the National Academy of Sciences of Ukraine. the head of the Department of Mathematical and Econometric Modeling of the Puho Institute for Modeling and Energy Engineering of the National Academy of Sciences of Ukraine. In the conditions of the development of green generation, the development of mathematical models of electric power system is an actual research. The uncontrollability and variability of electricity production volumes by generators of wind and solar power plants is constantly increasing. As a result, the load regimes of power units operating according to the traditional generation technologies are significantly changing. Therefore, in order to achieve the adequacy of models of electric power systems, it is necessary to use representative weekly intervals of mode forecasting instead of traditional daily intervals. And load modes of power units should be described in the form of unit commitment problems, which is a problem of mixed integer linear programming. In the unit commitment problem, operating costs for electricity production are minimized, including cost for start-up, shut-down power units. Usually, solving the unit commitment problem allows you to determine the evolution of the power system loading mode, startup from its known current loading mode, the initial mode. Such short-term forecasting of power system loading modes is carried out by dispatch management services. Long-term planning of the development of electric power systems using unit commitment problems for modeling the evolution of power unit loading modes is problematic due to the unknown initial power unit loading modes. Today, initial regimes are set a priori without any justification, which significantly reduce the adequacy of predictive solutions. To solve the problem of applying unit commitment problems in the tasks of long-term planning of the development of electric power system, the transformation of unit commitment problems with initial conditions into unit commitment problems with boundary conditions is proposed. At the same time, the boundary conditions ensure the cyclicity of solutions of unit commitment problems, which allows extending the weekly loading regimes of electric power systems to seasonal periods, which they represent in long-term planning problems. Now, how to make the transformation from unit commitment problems, transition from unit commitment problems with initial conditions to unit commitment problems with boundary conditions will be shown on the example of a fairly common formulation of such problems in the form of an objective function 1a. This is the sum of generation costs as well as the implementation of power unit shutdown, startup operations, and the group of restrictions which remain unchanged and are represented on this slide, namely balance equation of electricity production and consumption volumes, 1b, limitation on the required level of rotational power reserve, 1s, upper limitation on the load level of power units with the duration of startup periods of less than 1 hour, taking into account the maximum achievable load during the startup period, 1D. A ratio between the load level of power units and its initial values, 1I, 1G. The ratio between the accepted and potentially achievable load levels of solar power plants and wind power plants generators. Obviously, all the ratios presented here do not require transformation. Now let's turn to the upper limit of the load level of power units with the duration of startup periods of less than 1 hour, taking into account the maximum achievable load of these units during the shutdown period, 1E. The transformed view on the constraint is shown at the bottom of the slide, 10AB. Here, red dashes highlight the variable argument of the functions, and green dashes highlight the scope of the argument for the generated constraints that operate on the cycle time period. In the same way, we carry out the transformation of the upper limit of the load level of power units with the duration of startup periods of more than 1 hour, taking into account the maximum achievable load of this unit during the startup shutdown periods, 1F in 11AB. Transformation of speed limits for increasing and decreasing the load level of power units, 1G and 1H, into 12AB and 30AB respectively. Transformation of the balance equation of startup, load, shutdown states of power units, 1K into 14AB. The transformation of restrictions that are taking into account the low limit of the duration of the startup state of power units, 1L into 15AB. The transformation of the restrictions that take into account the low limit of the duration of the shutdown state of the power units, 1M into 16AB. The transformation of restrictions that determine the level of startup cost of the power that, depending on the length of the period that has passed since its shutdown, 1N into 17AB. Unit commitment problem of modeling loading modes of power units with initial and boundary conditions were used in planning the development of generating capacities of the regional power system with the generating capacities of solar wind power and nuclear power plants with small module reactors of the NuScale company. The results of computational experiments demonstrate a significant influence of the initial conditions on the load mode of the power units, and as a result on an adequate assessment of the efficiency of using power of the installed power units. As a result of the conducted researches, the following conclusion can be made. We have proposed a new mixed integer linear programming formulation of the unit commitment problem with boundary conditions, which is intended for application of autonomous weekly periods. The proposed formulation of the problem ensures the adequacy of optimization solutions in modern conditions of significant penetration of electricity production technologies from renewable energy resources and increased requirements for maneuverability and flexibility of electric power systems. Thank you for attention.
Thank you for your presentation. Dear colleagues, any question, please?
Honorary ladies and gentlemen, my name is SEnW-2023.
Yes, one question.
Please.
What class of objective function did you use in your research?
This objective function depends on the task necessary to solve. First of all, it's the function of the costs of operation with electricity power system. And this objective function express or consists the sum of cost of power for production of electricity and the cost of the operation with the startup and the shutdown procedures with the power units. And the cost of in total operational cost, it does not include into account the cost of electricity produced by wind and power plant, because the variable part of the costs with these technologies does not need to do so.
Thank you very much for interesting presentation.
Thank you.
I have one question, please.
You are welcome.
Sergey Evgenievich, at the beginning, you mentioned that problem solving based on prediction of cyclicity of power modes in system. How accurate should be this prediction? Aren't many of factors, including weather or cyber attacks or war, make any April week of 1 year different from previous Aprils?
Yes, thank you for your question. The methodology of the solving of the problem of the development of the generation capacity or transmission system in electricity power system formulated in so manner that it is necessary to reject in the model the specific behavior of the electricity system during the year, each year. The total forecasting period horizon, so-called horizon, forecasting horizon or planning horizon, divided on the with the steps equal 5 years, and each separated years must be reproduced in detail. And it means that in ideally, you must represent it all hour in this year, 760 hours. And it is a very big, very large problem, the big scale. And in such manner, there is no possibility to solve this problem. So it is necessary to divide the year on the months or in the seasons, and present it each month or season by specific time periods, reproduced the behavior of the system on these specific separated periods, in short periods. Traditionally, these periods determined as a day, 20 hours only, for months, for each month. But in our investigate, we show that it is necessary to use weekly periods. It means 168 hours. And in this period, we must take into account the typical behavior of the consumers in this period and renewable resources, the possibility to produce energy by renewable resources. So it is necessary to get solution in such manner that this solution can be spread on the season or the month it presented. And when we spread this solution on this period, we must need to do so, to do so correctly. And it is clear that if the solution have cyclicity behavior, it is possible to do so correctly. But when we solve the problem as the initial condition, it does not guarantee that your modeling solution on the short period can be spread on the total period, on the month or season. It's a conflict between the possibility of using unit commitment problem in traditional mode to the total period. And this problem is a title in the wild now, in the world. And you cannot find any publication that show how to solve this problem. And in this presentation, I show how we can transform the unit commitment problem with initial condition into unit commitment problem with a boundary condition, and to solve correctly this problem, how that permit us to modeling in short period, modeling behavior of the electricity power system on the total period, on the season or on the months. It's very important. Thank you for your question.
Thank you, dear colleagues. We must move on. And the next presentation is the conceptual principles of forecasting demand on the day-ahead market using changes in hourly bidded demand between previous similar day. I see author, and we can start.
Greetings, honorary ladies and gentlemen. My name is Anton Polukhin. and topic of my research is conceptual principles of forecasting demand on the day-ahead market using changes in hourly bid demand between previous similar days. Let's begin with typicality of my research. Day-ahead market is one of the core segments of the electricity market in Ukraine, where electricity is traded. It is important to understand market situation and to study structure of purchase and sell bids if you want your own company to be profitable, not even talking about economically break even. Forecasted demand for the day-ahead market, which is one of the components for successful activity on the day-ahead market, is considered within the scope of the article. Till today, in Ukraine, there are no easily accessible software solutions for forecasting demand for the day-ahead market, not even talking about short-term forecasting. Thus, my paper considers different algorithms for calculating such forecasted demand for the next day and comparing different approaches to the calculation with the selection of the most accurate of them. We need to make different calculations because we need to define the most and the best possible algorithm. As to the aim and goal, the developed algorithm should provide the 5 following principles. First, speed. Trading on the day-ahead market occurs from day to day, every day. So as soon as the results came out, we need to analyze, perform calculations, and start thinking about the strategy for the following day. Second and third, easy to use and easy to learn how to use. The algorithm should not require special skills or something ungodly for the end consumer to use it. Low cost of implementations. Well, it's easy to consider because all the analysis for the research was conducted in Excel, and the company should not pay millions of dollars for this algorithm to be implemented in the company. High forecasting accuracy, within 10%. Well, it's easy to understand if the algorithm is not accurate enough, who needs this algorithm at all. There are 3 basic principles for forecasting. First, using the real data results of the previous day. Well, it's easy to understand. When using the last possible results, we receive the best and the highest accurate, the most accurate results of forecasting. Using changes in demand between similar days of previous weeks. Just as an example, if we are forecasting demand for Friday, we analyze previous periods, Thursday, Friday, how our demand changed from Thursday to Friday, how it changed before from Thursday to Friday, and etc. Depth of the analysis is 4 weeks. Well, considering that the forecasting is short-term, we do not require to be depth of the analysis to be too deep into years and years and years. Factors which influence the demand on the day-ahead market. Well, there are several aspects which should be taken into account and probably discarded if these factors potentially distort our forecasting data. Weather. Well, it's understandable. Change in weather affects how our consumption changes. Bilateral contracts. Trading, suppliers, traders, they all perform operations before the day-ahead market. They purchase electricity, they sell electricity, and of course, they affect how our demand on the day-ahead market changes. Change in consumption of end consumer, for example, independent circumstances. Well, today we live in difficult times. We have war, and everything can happen to our end consumer. Electricity lines can be destroyed, something can be destroyed, so this cannot be forecasted. Possible manipulations on the day-ahead market. Well, if some player on the market have too much power, this player can use this power for his own benefit. Other factors, for example, mistake when inputting data on trading platform. Well, it's easy to understand. Sometimes some company may change, sell, and buy bid or make mistake when inputting price and volume. Calculation algorithms. Well, there are basically 4 approaches to the calculation offered in the paper. First one is the most obvious, arithmetic mean value of the change in demand. Well, we calculate change in demand between similar days 4 weeks ago, arithmetic mean, and then we this arithmetic mean add to the actual results of the our actual day. For example, if we are forecasting for Friday, we take Thursday results, add this arithmetic mean, receive forecasted value for Friday. Easy to understand. Next two following calculations, they use the so-called weighted average value. So the idea behind was to introduce some weight to receive probably better results. So these approaches use weighted average value of the sum of positive and negative changes in demand weighted by the number of days with a positive change in demand and a negative change in demand. Well, we all understand that demand can increase or decrease. Now, what is the main difference? First one, giving preference to those days that are more in number. Okay, it's understandable by increasing their weight, because they are more, it is more likely to happen if there are, for example, more positive changes than negative, and that are closer to today's day. It is second approach, and third approach, only giving preference to those types of days that are more in number. And fourth algorithm, it is derivation for it has derived from arithmetic mean probably and weighted average value of the two previous algorithms. It is weighted average value for positive and negative changes in demand. Well, sounds similar. Taking into account the deviation from the arithmetic mean of the absolute values of changes in demand to determine atypical days. So basically we need to determine these days which can distort our data, which can make our forecasting results look very bad. We need to discard these days, and therefore this method was discovered by the author experimentally to remove such atypical days. Example of results is written in the paper. Because we're kind of short on time, I'm skipping this information and just giving you the calculation results of all 4 algorithms. Well, algorithm 4 shows the highest forecasting accuracy. So how I determined the best accuracy? I used 2 parameters. First, sum of modules of absolute deviations is just absolutely numerical value and is only needed to determine the lowest possible value, because the lowest value of these sums is the best algorithm with the lowest amount of deviations. And times of being more accurate. Well, easy to understand how many times among these 4 algorithms these algorithms were accurate. And here on the slide, to the right side, we can see accuracy of algorithm 4, which was the best among the all 4 algorithms as to the previous slide and according to the study. And it shows example of one day. Here we have demand forecast value, the real data demand, and their absolute deviation. Absolute deviation and of course relative deviation in percent. It is worth to note that if there is high deviation in between forecasted data and real data, there may be possible manipulations on the day-ahead market, and probably the market operator should study the behavior of some players on this market. Well, basically, conclusions. Within the study, calculations of the forecasted hourly demand for day-ahead market was conducted using 4 algorithms. They could be somewhat similar, somewhat different, but according to these calculations, we determined the best one, the most accurate one. Formulaic description of this algorithm is presented in the article. It is worth to note that hourly demand forecasting is one of the keys to successful business in the energy market of Ukraine, and this provides competitive advantage over other market participants who do not perform such forecasting. The report is complete. Thank you.
Thank you for your presentation. Dear colleagues, any question, please?
Sure, I can ask a question.
Yes, you're welcome.
Can you please explain how you take into account in your algorithms the weather when speaking about power energy system of Ukraine? A large country, pretty large country. Thank you.
Thank you for your question. Well, basically, the weather is one of the factors that may influence the final value of demand or consumption. But in this algorithm, there is no direct link on how to include changes in weather and their impact on the results. So, I mean, the algorithm does not directly study the weather. Well, it's understandable, but for example, if we have one day when the weather was abnormal, for example, we have like June, it's very hot, and one day was not very hot, and the consumption changed, the algorithm will, let me say this, it will discard this day from the calculation. But there is no direct influence of like temperature, for example, on the final result.
Okay, I have more questions about this, but let's move to our chat, okay? To let others to continue.
Yes, and I remind about our chat. So the next topic is line electrical transmission damage identification tool for distribution electrical networks. I see authors, and we can begin.
Good day, everyone. We present a report which based on the result of studies the next topic, line electric transmission based damage identificator tools in distributed electric networks. The actuality of this exam is determination by important direction of improvement and construction of electric power networks and system according to the smart grid concept as in the world and in Ukraine. The main idea of such system is a reliable, energy-effective, and high-quality energy supply, which based on the growing role of management as a leading factor in the innovative development of the electric power industry and the construction of the high-performance information and computing infrastructure. One of the main components of smart grid is means for diagnostic and damage monitoring for distributed electric networks. Because damage of electric networks affects the quickly and reliable of electric supply to consumers. So the task of quick and accuracy determination of the place of damage is important. The effective solution of these problems gives a significant economic effects due to the reduced or interrupted its power supply. The reduction of transport cost of bypassing electric networks, and the minimization of the tools time of organized repair and restoration works. The goal of the paper is to analyze the ways of increasing the reliable to effective supply to consumers and the effectiveness of restoring electric supply by operators of distribution system by development a structure of means of identify energy condition in distribution electric networks of IPS of Ukraine. So energy identifier tools is section of cable and overhead electric networks way to improve effectivity of the network. Way to increase effectivity is the use to means of identify energy condition in sector of the both cable and overhead electric network. The damage of the placement, a diagram of the placement of damage indicator on the section of the electric distributor networks present, which allow determination and direction of the search for the location of the damage. On slide showing advantage and disadvantage of using damage identifier tools in electric networks. These are next. Identifier tools are used to determine interpath short current and single path short current to the ground. Detection of a stable and unstable damage, determination of on the type of neutral in distribution network is avoided. Damage identifier tools for determination the location of damage do not finally means a number of the new and specify requirements for the organization of the process of connection, control and diagnostic of the operation of the distribution network, which are advanced to the electric power system built according to the smart grid concept. The disadvantage of the damage identifier tools is dependence by a coding of measuring current transformators and proceeding tools. The identifier problems largely determine the need for the development and implementation of damage identifier tools and the corresponding information and measurement system of domestic producing, which must take into account the construction and structural feature of the distribution networks of the IPS of Ukraine. To eliminate the disadvantage development, the scheme of the damage identifier structure you can see on slide. A block diagram of the specialized information measuring system which a damage indicator was created, taking into account the requirement to this smart grid concept, which allowed to reduce the time of searching for the cause of minimum. Damage indicator structure consists a load current sensor and information and measurement system. The current sensor consists a non-invasive current sensor, which consists of an inductive current transformator with a collapsed core, a resistor designed to convert the value into voltage, a shift reference voltage stabilizer implemented on analog elements. Experimental sample of damage indicator structure based on the smart grid concept. It was established that the sample can determine the voltage of the short current circuit up to 600 ampere with error of the more than 0.1%. The result of the study of the experimental sample of the structure of the damage indicator based on the smart grid concept confirmed the correspondence of the accepted theoretical calculation and provision. Thank you for your attention.
Thank you for your presentation. Dear colleagues, any question, please?
Dear colleagues, dear organization committee, we are grateful for our possibilities.
Just one question regarding sensors.
Yes, you're welcome.
Yeah, as I understand, it's some sensor which can evaluate if its grid is on or off. But how you will power your sensor if grid is off? How it can tell the system that it's loss of energy?
Thank you for the question. In implement of device, we have two power sources. The power source from line, if all functional correctly, and power source from accumulator, which is used if online power is cut off.
Okay, thank you.
Any other question? No any question? Discussion? Comments? It's okay. I have a very short question. Can you tell me about the future direction of your research? But short.
Thank you for question. In future, we
use the system on real lines. Now it's just experimental example, and in future we make system for diagnostic real electric network line.
Thank you so much. So we must move on, and the next presentation, I see the author estimation of probably the double spend attack in the post-consensus protocol using checkpoints. And we can start. 1 second, please.
Dear colleagues, dear organization committee, we are grateful for our possibility to present our results on this conference. We propose you our new results on building upper bounds for probability of success of double spend attack for one of the modifications of proof of stake consensus protocol on blockchain, so-called proof of stake with checkpoints. Since 2008, there were a lot of investigations of different consensus protocols on blockchain about their security against different attacks. As for double spend attack, we may name several works devoted to security against this attack. First of all, this is Nakamoto's article, his single article in 2008, which gives a general view on blockchain. He also gave them tools to increase security against double spend attack, and also estimated probability of the success of this attack. But unfortunately, his results, those concerning probability of attack, his results turned out to be wrong from a probabilistic point of view. The first completely proved results were obtained by Greenspan and others in 2017. They get results of probability of double spend attack for blockchain with proof of work consensus under the assumptions about continuous time and zero time delay. The next work in this direction is about probability of double spend attack for blockchain with also proof of work consensus, also continuous time, but with a non-zero time delay. So this work is a generalization of previous one. It were results of me and my colleagues, and this work was published in 2020. And the next probability of double spend attack for blockchain with proof of stake consensus under the assumption of zero time delay, and it was classical proof of stake consensus without checkpoints, were obtained by me and my colleagues in 2021. And the purpose of this research is to estimate the probability of double spend attack in blockchain based on proof of stake consensus protocol with checkpoints, to find the necessary number and confirmation blocks which guarantee that the probability of attack is negligible, and to compare security against this attack for blockchain without checkpoints and for blockchain with checkpoints. Blockchain is a digital ledger resistant to unauthorized access, implemented in a distributed manner without a central governing body, maintained and managed jointly by a distributed group of participants. There is no centralization in the system in the form of financial institute, banks, or something like this. As you can see on this picture, each next block contains in its header the hash of all data from the previous blocks. So this construction is very similar to chain, and that's why it is called a blockchain. There are a lot of different consensus protocols on blockchain, but the more popular and more wide used protocols are proof of work and proof of stake. Proof of work is a consensus protocol based on large amount of hashing, and proof of stake is a consensus protocol model that depends on how much money each user has invested in the system in the form of cryptocurrency. Such users are called stakeholders. The larger stake of stakeholder, the larger number of blocks he may chance to create. Points are some control points, blocks in blockchain, which freezes the history of blockchain. It means that all blocks which are deep enough in blockchain can't be changed even if a longer alternative chain appears. There are a lot of examples of cryptocurrencies with checkpoints for both proof of work and proof of stake protocols. So such modification of proof of stake protocol is widely used. A classical double spend attack on the proof of stake protocol means that an adversary creates a hidden alternative chain which contains some alternative transaction to one of transactions in other chain published by honest miners. On this picture you can see blockchain with checkpoints. Some block contains checkpoints, and on this picture you can see a visualization of double spend attack. This is a chain published by honest miners, and this is hidden chain published by adversary. Not published, but created by adversary, and adversary publish this chain even in case with this chain becomes longer than the chain published by honest miners. Adversary tries to create two alternative transactions, one in the first chain and the second in his hidden chain, and these transactions are alternative in the sense that they both spend the same coin, and that's why this attack is called a double spend attack. The attack is successful if the attacker managed to build a chain that is longer or at least equal as the chain that was published by honest miners. An explicit expression for the probability of a double spend attack in the classical proof of stake consensus protocol without checkpoints is given in this theorem, which was proved in 2020. Here P is share of honest stakeholders. It means total stake of honest stakeholders. Total stake ratio of honest stakeholders. Q is total stake ratio of malicious stakeholders. Z is numbered confirmation blocks, and K, which is some variable, is the number of blocks created by an attacker. The results for proof of stake protocol with checkpoints are much more complicated, and the proof also needed a lot of work. This picture explains how proof of stake consensus protocol with checkpoint works, the first picture, and this picture explains how the attack is run. The main feature of such attack for this type of consensus is that adversary needs to complete this attack before the next checkpoint. So it is harder for adversary to succeed in this attack. We get an explicit expression for the probability of a double spend attack for a proof of stake consensus protocol with checkpoints, and as you can see, this expression is much more complicated than previous one. Their designations are all the same, except one. In this formula, we need one more designation. N is the distance between two checkpoints. This distance is measured in the number of time slots. And the numerical results given on this and on the next slide, according to our formula, show that the probability of double spend attack for proof of stake protocol with checkpoints is smaller than for proof of stake protocol without checkpoints, just as it was expected. And also, you may see, for example, when we have large adversary ratio, that the difference between probability of double spend attack for blockchain without checkpoints and with checkpoints, the larger stake ratio of adversary, the larger is difference between the probability of these two attacks. And that's all. Thank you for your attention. Maybe you have any questions. I will be glad to answer all your questions. Thank you.
Thank you for your presentation. Dear colleagues, any question? I have a first question. Could you talk about the prospects of using your result for energy sector?
Hello, can you hear me?
Yes.
Okay, thank you for this question. This explanation should be in slide number 1 or number 2, but unfortunately we lost this because I was concentrated on different mathematical questions, and now I'm glad to explain this connection. The matter is so-called smart contracts, which may live only in blockchain. Blockchain is a natural environment for smart contracts, and these smart contracts is a very nice tool for peer-to-peer trading with green energy. And if we want these smart contracts to be secure against different attacks, we should provide blockchain security against these attacks. So in this report, we estimate probability of one of the attacks on blockchain, and if such attack is successful, it may cause not only some double spending, but it may cause a changing of blockchain history. And for example, some smart contracts may be not fully completed. Maybe some smart contracts may obtain money for some amount of energy and then don't work properly or something like this. So to provide secure and correct functioning of smart contracts in any area, we should first of all to guarantee the security of blockchain. So that's all.
Thank you so much. As a reminder, your article, you wrote about the energy efficiency of your algorithm. Can you tell more about this?
About efficient of peer-to-peer trading?
No. About the energy efficiency of your algorithm.
What algorithm? We didn't propose any algorithm. We only estimate the blockchain security against some type of widely used attacks.
Okay. Okay, dear colleagues, any other question? Don't see any. So thank you for your presentation. We must move on. And the next presentation is energy efficient computing by using of software optimizing aimed of execution time. I see the author and we can start.
Hello, everyone. My name is Serhiy Sushko. Me and Alexander Timoris, my colleague, would like to introduce our paper, Energy Efficient Computing by Using of Software Optimization Aimed on Execution Time. As you can see, it's related to software optimization in context of energy efficiency. As you can see on the picture, energy efficient computing is required to reduce resources. This is less electric usage, less heating, and less operational costs. If to review dissipations of electric power in integrated circuits, we can find that it has several subparts. Static power is in every time of working. It does not relate it to everything, but dynamic power is used on only with switching of circuits. It means that without any switching, it will be zero. What is the relation between software and hardware, especially of electric power consumption? As you can see, if we have some software code, it will be compiled or produced to any another way for central processing unit. After it, then it will be executed by CPU. It will switch some electric gates, which, as we saw before, will produce electric power, which require electric power and produce power dissipation. It will require some cooling system. What can be told about software optimization? In common, software optimization can be divided on three big domains of optimization itself. It's different sides of optimization. They can add to each other and improve each other also. So this is algorithm optimization, which is related only on high level algorithm. Macro code optimization, it's how algorithm is performed by commands of CPU. And microcode optimization, it's how CPU commands are compiled to executional code. Our task is related only to macrocode optimization, which means that we don't change algorithm itself or made some CPU improvements. We just change our code and try to find better solution. Actually, there are a lot of methods of optimization. One part of it is methods of optimization of computational loops. And it's used only while a code is related many times. As you can see, there are a lot of them, but it's not everything. And some of methods like parallelization and tiling are highlighted. Parallelization, this is a computational, it's an optimization and computation are split it onto several processors. And tiling, this is another method. It's a little bit harder to understand, but if we will see on the picture right now, we can see that it has, if we have computational loop with two axes, but it can be 3, 4, 5 dimensional, it doesn't matter. This is just an example. And the tiling method is an idea to divide it by smaller blocks. Actually, this is our tiles. And compute it with lesser increment of iterations. Also, such blocks can be divided on several processors, and it also boosts speed of the computation. So what we have here, this is Pluto software. Actually, this is a special tool which allows us to use different optimization methods in automated way. So we put some code on it. It will do all the job, and at the end of it, we will have another source code which can be used and compiled as regular code. So here we can see some parts of Pluto software. This is actually a framework which requires another parts to work properly. So just to let you know how it works, let's have a look on it. So from left side, we can see how regular software is used. So we have some source code, we have some compilation, and we make program execution on which we can measure execution time. While in optimization, we have another thing to do. This is source code transformation. So after original code, we have some optimized code, and then we do again some compilation and program execution. On each stage, we also can measure execution time. So what we've done to discover it, we took Raspberry Pi. We took Raspberry Pi board, which is a single chip architecture. This is ARM architecture, and it's quite small, but has a lot of ports, a lot of possibilities to make some computation, IoT, domestic usage, file server, and so on, so on. It's powered only with power supply, which can be USB. So this is quite low power device, but for some cases, this is enough to use. Also, it has some GPIO pins. It can be attached to some external device like sensors, cameras, whatever. So we discovered that board. And what is the methodology? So if we would like to measure time of everything, of execution time, we know what to do. We need to measure before and after. What we need to do to measure energy efficiency. So we introduce the coefficient, which is on the bottom top of the page, but we obtained it as follows on the picture. So we have some energy, we have some power, and actually this is a division of energy before and after. If voltage is the same, so it can be eliminated, and we have actually multiplying of two relations of execution time and current consumption. So actually what we need to do to compute energy efficiency is just to find out these values. So actually, as you can see, it's just 3 steps to do it. First 2 are measurement of execution time and average current consumption. Actually, this method is also good for another boards. So if we, for example, if we use big PC, which uses some power from electric grid, and we have some instrumental and tools to measure power, not current. So actually, it's also related to it. We need to measure power and use the same formula. And final stage, it's computing of energy efficient coefficients, as we saw before on the formula. So when we done it, we obtained such formula, such plot. On the plot, you can see different values for different optimization methods, which is mentioned on the top of it. Horizontal line is different test programs which we used. It's about 25 of them. And vertical X is actually energy efficiency coefficient. How to treat it? If it equals to 1, it means that nothing happens and energy efficiency is the same. So if it's bigger, it's better. If it's lower, it's worse. So as you can see, it's very different on different softwares. In top case, it can be up to 5, but regularly is 2 or 3. Also a lot of tests which is around 1, so it's no significant energy efficiency improvement. But for some case, we can see that it can be only half of it for one test. So it means that no energy efficiency was achieved and everything went even worse. So also in common, it means that not every optimization software can lead to energy efficiency. And it should be discovered in particular in every time. And also, it's a good idea to check particular optimization methods, also in particular software. So just to conclude everything, why it happens, we can see that in some cases execution time reduces, even for a single thread. And another factor is that even power consumption is increasing for multi-thread usage, but speed up is even better. So in that case, energy efficiency will be better than before. And also some particular optimization cannot give speed up and also will not give us any energy efficiency. So thank you very much. And please give me some question for you.
Thank you for your presentation. Dear colleagues, do you have any question? If any, I will start. As I remember your article, there are no reference to whether computing power efficiently improves in the same test run on other hardware platform. Can you tell me more about the performance on other hardware platforms?
Okay, so thank you for your question. So we did such tests for different platforms. And for tiny platforms like microcontroller, we use it into 51. There are no improvements at all because it has the same memory logic, no cache, no some specific boosts. And also, of course, it has only one computational unit. But for more sophisticated hardware platforms, like the usual desktop, which is more powerful than Raspberry Pi, we saw that its energy efficiency coefficient can be even better. So, because we have a very big cache, we have more cores, more computational cores. So everything because of it. And because tiling itself makes an improvement of memory locality, for such cases, it's made bigger energy efficiency. So to be short, if more sophisticated and complicated hardware system is used, then more energy efficiency can be achieved.
Thank you so much. Any other question? Don't see any question. Thank you for your presentation, and we move on. The next presentation is on the topic analysis of the dynamics of the development of alternative energy plants in the term of their connection to the power transmission networks. I see the author, and we can start.
Hello everyone, my name is Yana Lukashevich, and the topic of my presentation is analysis of the dynamics of the development of alternative energy plants in terms of their connection to the power transmission networks. In recent years in Ukraine, there has been steady development of small or low-capacity power plants using renewable energy sources, which gradually replace traditional methods of generation. According to the data from the State Agency for Energy Efficiency and Energy Saving of Ukraine, the installed capacity of power generators from alternative energy sources increased by 9.5 from 2014 to 2021, as shown on slide. However, after the full-scale invasion by the Russian Federation, the Ukrainian energy sector suffered destruction and requires restoration. It is important to identify new approaches and methods for supporting and developing alternative energy producers during both wartime and post-war periods, as the existing green tariff is insufficient. There has been a heated discussion in various professional circles about decentralizing the power system in the context of post-war reconstruction and reflection. To conduct research on the development of distributed generation in Ukraine and introduce new approaches and methods of supporting renewable energy in the war and post-war periods, it is essential to have data on the current state of renewable energy, and as well as information of the capacities of renewable energy facilities that are connected to the distribution networks. Based on this, the aim of the research is to analyze the dynamics of the development of alternative energy facilities in terms of their connection to power grids. As shown on this slide, the installed capacity of operating renewable energy production facilities increased from about 5,000 MW in 2019 to 8,000 MW in 2021. However, due to military aggression in 2022, only 6,800 MW of operating capacity of alternative generation facilities remained in the unified energy system of Ukraine. Thus, there is a trend towards the predominant connection of alternative generation plants to distribution grids, likely due to the low installed capacity of renewable energy producers and the relative simplicity and cost effectiveness of connecting to distribution grid compared to the high voltage grid. The next slide shows the distribution of installed capacity of operational alternative generation stations categorized by source of alternative energy and they are connected to the power grid for the year 2021 and 2022. Because of the war, some of the alternative generation facilities were destroyed, damaged, or landed in occupied territory. Wind and solar power generation has declined by more than half from pre-war levels. The following factors may serve as explanations. First, the destruction of power generation as a result of direct hostilities. Second, the increasing problems related to the destruction of demand and high inflexibility of power generation. And third, increasing problems related to damage to energy infrastructure, networks, substations, etc. As of July 2022, renewable energy facilities connecting to high voltage grid include solar power plants in the Dnipropetrovsk, Lviv, Mykolaiv, and Khmelnytsk region. More than 5,000 MW in solar power plants, 476 MW of wind power plants, and 334 MW of plants generating electricity from other sources were connected to the distribution grid. These plants are distributed through the territory of Ukraine, taking into account the geographical and climatic conditions of the regions. Currently, the only mechanism to promote the development of renewable energy in Ukraine is the green tariff. It's a special tariff for the purchase of electricity from renewable energy sources. However, this is not enough. The financial crisis in the RES market is deepening, and percentage of payment under the green tariff is decreasing. Therefore, it's extremely important to find new mechanisms and ways to develop renewable energy producers. According to the 10-year plan for reconstruction of Ukraine, published by the National Council for Reconstruction of Ukraine after the consequences of war and presented for the first time at the Ukrainian Recovery Conference 2022, the main direction of development of Ukrainian energy industry are defined as follows. Integration with the energy system of European Union countries, next decarbonization, also optimization of the energy mix and balancing of the energy system, and the last one, increase of the energy efficiency. At the same time, as the research shows, 90% of the capacities of producers from alternative sources are connected to the distribution networks. Therefore, the development of renewable energy is one of the important points on the way to decentralized energy system. Also, the development of decentralized energy system can be one of the mechanisms to support the development of renewable energy. In particular, the development of distributed generation will provide energy independence and increase of the security of energy supply to the communities of Ukraine. The government proposed to provide mini power plants and small generation facilities that will be integrated into the existing power grid. Another step towards to development of distributed generation and development of renewable energy is the introduction of virtual power plants. In addition, the concept of creating a solar energy networks is being considered for territorial associations. Solar energy network is a set of energy generation and storage centers connected to each other to consumption centers in a given area. So, as a result of war, the power industry in Ukraine in general and more than 1,000 megawatts of renewable energy capacities in particular need restoration. One direction of the evolution of the domestic power industry in the development of a decentralized energy system to provide energy independence and security for the citizens of Ukraine. The result of research shows that about 90% of generation capacities are connected to distribution networks. As a consequence, renewable energy is an important part of distribution networks. Therefore, the issues of supporting alternative generation and the development of distributed generation are interrelated, mutually complementary, relevant, and require further researches. Thank you for your attention.
Thank you for your presentation. Dear colleagues, any question? I have a first question. Can you tell us more about why the network connection analysis was conducted?
For me, it was important to understand what the current state of development of renewable energy sources facilities and what part of the capacity is already connected to the distribution networks in which regions their stations are located. Considering this, it is possible to continue to look for new methods of supporting the development of renewable energy in Ukraine. Also, this about looking new methods of supporting of renewable energy in
take in account the conception of decentralization of the energy system.
Yes, thank you. I see Vitaly Vitaly, welcome.
Thank you. Can you please tell more about this concept of virtual power plants? What is it?
Virtual power plants take
It was on your slides.
Yes, one minute. I want to open my presentation. Virtual power plants. This plants. That's a conception of connected different connecting different
Producer.
A different producer of electricity and also the consumer of electricity in one mechanism, in one net.
Both producers and consumers, and
yes,
this connection is called as a virtual power plant. Yes. Thank you.
Yes, you're welcome.
Thank you. What is your opinion about the necessity of using special market instruments in order to stimulate the decentralization of the development of renewable power stations in Ukraine?
Thank you for interesting questions. Question about market. Can you repeat market? I'm sorry.
Marketing tools.
Marketing tools.
Instruments, market instruments. Maybe it is necessary to introduce special instruments for stimulate the development of renewable resources and the decentralization or distribution power networks. You show the significant difference between the development of renewable sources in the regions and in the united energy system of Ukraine, and 10% in united and 19% in distribution system, and how to stimulate these processes. The decentralization of the producer producing of the energy, it's it is obviously, but how to support this tendency by market instruments, by market signals?
So this is the topic of my research, and I am looking for different methods and instruments that can be applied, but it requires to study. I cannot transfer to you now how it exactly should use, may use.
So,
I have only one comment to this answer, my question, and the comment is when you investigated the development process of the renewable resources, renewable equipment in Ukraine, it is necessary to include in this investigation the questions concerning the power market and how power market influences this processes, because you can observe that the government constantly changes the law in electricity market in order to support the development of that decentralization processes in the power system of Ukraine. And first of all, it is necessary to investigate the electricity law, and their influence on these processes is very important factors that determine the future of these processes. Thank you.
I understand. Thank you for so useful comment. I will use it in my future researches. Thank you so much.
Thank you, dear colleagues. We must move on. And the next topic is assessment and enchantment of digital resilience in the energy crisis caused by missile strikes. I see authors, and we can start.
Dear colleagues, good to see you at our workshop. This presentation devoted to digital resilience of Ukrainians and Ukraine in the energy crisis caused by massive missile strikes. Digital transformation is a process of sustainable development of a digital society whose economy based on information technologies. The semantic field of digital transformation includes such concepts as the digital economy, digital skills, digital rights, e-government, digital innovations, and much more. The digital component of existence requires a significant value and becomes an object of attack. And the ability to resist an impact on the digital component of our being is known as digital resilience. Digital resilience has dual nature. It characterizes how successfully and constructively one overcomes challenges and adapts to changes using digital technologies. And also digital resilience includes resilience in digital environment, how successfully one is able to achieve aims effectively using various info-communication systems. Digital resilience can be a property of an individual's, communities, businesses, societies, and the state. It is subject to analysis, measurement, and improvement, and much attention is spent to resilience of cyber systems, which are tightly related to power energy system. The experience of Ukraine is extremely valuable for the study of digital resilience. Ukraine was among the leaders of digital transformation before the large-scale Russian invasion. Missile attacks on the main facilities of the power industry lead to wide power outages. In December of 2022, multi-day outages took place. It is predicted that next winter will not be easier for Ukraine. Each business and each household must constantly review their survival options with new impacts on power grids. We must be resilient. In our opinion, science should contribute to the development of mechanisms of absorption of negative impact, adaptation and evolution of information and communication systems. This requires the collection, analysis, and systematization of existing experience. We propose to define a digital ecosystem of digital subscribers, their digital needs, and digital means or digital tools, which can be used by digital subscribers to achieve their digital needs. While digital needs can be represented by remote work and electronic payments, distance learning, e-health, state services like electronic registry access, and very important need of electronic socializing. Digital tools are very vast number of information and communication infosystems, which provide the ability to achieve those needs. I think there is no need to provide obvious examples of such info communication systems. To increase digital resilience to threats related to major power outages, the following tasks must be solved. To investigate most sensitive digital needs and digital subscribers. To analyze cyber threats that large-scale power outages pose and how they affect the digital needs. To analyze existing and available network architectures, types of electronic communications, data transmission systems, topologies, and determine how resilient they are to high-impact events in power grids. And finally, to find the most effective combination of digital tools which subscribers can use to satisfy their digital needs. Those three sets, digital subscribers, digital needs, and digital tools, form a variety of tuples of 3 elements each, based on existing and available combinations. Then there exists a heterogeneous set D, which includes all the 3 sets of digital subscribers, digital needs, and digital tools. Then let's T is a system of elements of this set, which includes all possible digital ecosystems, namely all possible communications and combinations of those elements, unions, and intersections of this set. Then T corresponds to the definition of topology on the set D, and that couple T and D corresponds to definition of topological space. Individual elements of the topology represent network structures that can be researched using graph theory, complex network theory, and topological space theory to develop models and methods to enhance digital resilience. To explain the way, let's look inside those structures, and we will see the key role of information and communication systems, their diversity, and also the diversity of their vulnerabilities to energy problems. Despite great success of air defense of Ukraine, we should expect a new wave of missile and drone strikes on power energy infrastructure. This will be a long test for the modern digital society based on information technologies and electronic communications. At this slide, figure shows a generalized individual-centric digital chain that connects a digital subscriber with a set of digital needs using a set of digital tools. As we can see, the key element of digital resilience is the tools of electronic communications, DT set. The initial element of digital resilience is the digital subscriber, DS, consumer of digital services. This is either an individual or a legal entity, and their needs vary, and their ability of tools for them is also slightly different. The risks associated with the lack of electricity power affect all elements without exception, but not to the same extent. Let's review what lessons Ukraine learned during last winter. We studied many use cases and user experience of interruptible power supplies, beginning with relatively cheap consumer models and also DOI systems based on car starter batteries, special devices to power up home routers and switches, and different battery types. Also, we collected use cases about attempts to use private power generation, solar and gasoline stations. We found and systematized many pros and contrasts for each technology. Then we reviewed the use cases of different internet access providers, their network technologies, and found significant difference to their resilience to power outages in a communication system level. We can return to these collections in a section of in the question sections. And so let's generalize given examples. According to proposal classification, the chain from a digital subscriber to a digital need at the very initial stage contains a large number of options for ensuring the digital resilience of the subscribers and their tools. Each digital tool can be analyzed and compared with others that provide a similar result. But to generalize the result, the most promising is the development of metrics that characterize the most effective resilience tools based on their availability, cost, time of implementation, reliability, and other properties. This metric approach approved by many researchers and can be combined with risk management theory. Such risk-aware metrics can be also introduced to evaluate digital resilience. For this purpose, we offer to review each property of a digital tool as a component of risk, either a factor of cost or factor of likelihood. For example, let's define some of properties of digital tools. Cost. How much does it cost to get this digital tool and use it? Accessibility. Implementation agility. How easy is to access this tool or switch to this tool. Reliability. A measure of the ability to perform the required functions in the given modes and conditions. And power autonomy. How much independent this tool is from power outages in comparison to other functional equivalent digital tools. Then, it's possible to evaluate digital resilience for an average household digital tools, which include redundant power supplies, diversified internet access providers, personal awareness, how to alternate power source for internet access equipment, and so on. And similar considerations can be made when analyzing a network providers and data centers and each element of the entire chain between the consumer and the service. And that's the conclusion. Representation of individual components of the digital world in the form of topological space opens the way to learn the problem of digital resilience through the research of group properties, characteristics, dynamics of a large number of network structures. In the future, the study will provide an analysis of means and measures to ensure the resilience of digital services providers during the crisis of the electric power and industry. I mean, online stores, public information services, large data centers, which host these services. In addition, it is necessary to develop metrics that characterize the effectiveness of resilience tools based on their availability, cost, implementation agility, reliability, and other criteria. Thank you for attention.
Thank you for your presentation. Dear colleagues, any question, please?
May we use the term resilience, and this term traditionally in medicine determined the possibility the people to restore their health and after any crisis. And the similar one, we use the similar meaning of this term in energy. The resilience means that you must possibility to quickly restore the functionality of the system after the crisis with this system. And you're supposed to use this term in order to change the energy supply of the information systems. So it means that you guarantee the better stability of working these systems, but not resilience. What do you think about this?
In the common meaning of resilience, there is there are several steps. There is an impact which starts the degradation of system, and there is a point of stopping degradation. Resilience cannot be an absolute, cannot be measured in absolute figures, in numbers. It can, in my own opinion, resilience can be compared with itself before and after some changes and evolution of system. What do we mean when we call some IT systems more or less resilient? How fast they can be recovered? How fast is it possible to replace their functionality of some modules with another modules? Do you have enough skilled personnel who can dare to try something with this system, to do with this system when it's not functioning sustainably? What does resilience in biology? It's maybe a bit different. The term of resilience came from biology.
No, I mean that not only biology, in medicine, in anything, the resilience means the possibility of the system to restore its functionality after something wrong with this system. After, not before, not inside this system. And you propose to change, to make changes inside this infrastructure, the information infrastructure, inside. You prepare the infrastructure system to these actions.
Yes.
Yes, and this it means that it's not resilience, it's a stability. You guarantee the stability of continue to work this system. This different this situation differ from the crisis that happened with the system. With the system, and this system does not prepare to protect from this act, from this crisis. Is typically for a body, for a human body, is typically for biosystems, is typically for energy power system, and so on. Any happened that cannot be the system does not prepare for this action, for this influence on the system. And the reaction on this influence, a reaction of this influence is the resilience, the possibility to restore, to quickly restore after the influence, not before. It's very important to understand the resilience.
Let me answer your question. If you say the resilience is beyond risk management, I totally agree. Resilience is absolutely beyond the risk management. Resilience is a property when risk management failed. And what is resilience? For example, for providers, internet access provider system, there are two providers with different technologies. And it was, for example, earthquake. All the cellular provider towers fell down. However, providers who provide telecommunications by copper cables in underground copper cables, their technology survived. And mobile providers quickly adapt their networks to transmit data to another regions using existing cables. This interconnection, this co-working is a kind of resilience. How people connect to each other. Can people connect to each other using using what? Using SMS?
Yes, I agree with you. I agree with you, but we described the situation after something happened, something wrong. After, not before.
But we are trying to
It's a resilience. It's a resilience to this plan, this organization of the work in order to restore the functionality of the system means that it's a resilience. The possibility to restore functionality quickly and the time you spend on this operation in order to restore the functionality is a resistance, is a shortly, is more higher of level of the resistance. But if you propose to install the accumulator, to guarantee the continue to stable work of the infrastructure, is a stability of the system, stability to continue functionality without looking on the missiles and so on, and earthquake and another not predictable and not estimated influence on the infrastructure.
Dear colleagues, to start your discussion, and we must move on. Thank you very much. And the next presentation is research and calculation of the levels of high harmonics of rotary electric machines in active adaptive networks. I see the author and we can start.
Good day, dear participants of the conference. To your attention is presented study on the topic Research and calculation of the levels of high harmonics of rotary electric machines in active adaptive networks. The quality of electrical energy significantly affects the reliability and efficiency of electrical networks and power equipment. One of the important indicators of the quality of electrical energy is the level of high harmonics, which causes non-sinusoidal modes of operation of electrical networks. Modern trends in the development of electrical networks, namely the introduction of active adaptive networks, introduce new aspects regarding the quality of electrical energy. The study of the nature of individual harmonics is of significant practical importance. This is confirmed by the study of, for example, third saturation of the magnetic circuit and tooth harmonics, which appear as a result of the unevenness of the air gap of rotation electrical machines. Therefore, the study of groove harmonics is relevant. The purpose of the study is to obtain scientific result regarding the nature of groove harmonics, of rotation electrical machines and to establish the characteristics of their distribution in electrical networks. High harmonics of distribution electrical networks have a constructive or technological nature. Each harmonic component has one or more sources and defined propagation space. The amplitude value of the high harmonic and its flow path are determined by the interaction of the inductive and capacitive elements of the electrical networks. The most unpleasant case is the case of resonance of higher current or voltage harmonics in electrical networks and large enterprises. The manifestation in time determines the random or systematic nature of high harmonics. In the process of operation, electric rotary machines generate groove harmonics in the electrical network. The appearance of these harmonics is related to the magnetomotive force of the rotor winding. Their frequency can be determined by the expression 1. The amplitude value of these harmonics is determined by the design parameters of the electric machine and the network voltage. The significant downgrade of groove harmonics is caused by the dependence of these frequencies on the network frequency and slippage, which can lead to resonance phenomena. The energy level of the slot frequency induction harmonics characterize the magnetic losses in steel from the slot or the magnetic field. Specific magnetic losses in steel are determined by the expression 2. In the general case, taking into account all terms of the Fourier series, for specific magnetic losses from the upper slot frequency in induction, obtain the expression 3. Thus, the specific magnetic losses from the upper groove harmonic of the induction depend on the value of relative electromagnetic asymmetry. The nature of this dependence is completely determined by the nature of the graph in figure 1. When determining the losses by the coefficient k, taking into account only the first two members of the harmonic series, the relative error of the calculation, with an electromagnetic asymmetry of up to 50%, does not exceed 2%, and then it begins to increase. Figure 2. Calculation of the third term of the harmonic series significantly increase the accuracy of the calculation. The error in determining losses by the coefficient k does not exceed 2% with asymmetry up to 80% and increases to 8 plus 10% with an increase in electromagnetic asymmetry up to 90%. Figure 3. The study proposes a method for determining the energy level of high harmonics, which can be estimated by the sum of the squares of electromotive force of groove harmonics, taken then each of the three phases of the starter winding is turned off sequentially during the operation of the electric motor. When the electric motor operates in the three-phase mode, taking into account the spatio-temporal distribution of the slot frequency induction for the slot harmonics of the first order induction, obtain the expression 5. The proposed technique allows determining the energy levels of high harmonics not only taking into account the value of absolute and relative asymmetry, but also taking into account the direction in space of the plane of asymmetry in relation to the distribution of the stator windings. The dependence of the electromotive force of the grooving harmonic of individual phases and the sum of the squares of the amplitudes on the magnetic electromagnetic asymmetry was calculated on an electronic computer. Figure 4. The developer technique makes it possible to determine the levels of groove harmonic components in the phase windings of electric machines. These harmonics depending on the connection scheme of the asynchronous motor winding, start delta. The scheme and the load of the electrical network spread over the electrical network, creating current harmonics or voltage harmonics. All asymmetric emergency damage in the electrical network, disconnection of phases, short circuits of individual phases to each other and to the ground, can be displayed quite simple then forming nodal equations, taking into account the corresponding commutation in nodes and branch of a three-phase network. Moreover, the presence of several asymmetric damage does not lead to any complication in the algorithm for forming and solving nodal equations compared to the case of local damage. Therefore, mathematical models based on equations in phase coordinates are more flexible and universal, applicable for the analysis of non-symmetric modes of operation with both simple and complex asymmetry. It was established that the levels of groove harmonics are determined by the structure and modes of the electrical network, the geometry of the groove zones, of the air gap of electric machine and its magnetic properties. The last slide presents the conclusions of the study. Thank you for attention.
Authors. For the presentation, have any question? But very short, please.
Very short. Please, what is the range of frequency of this harmonic, and how to determine this harmonic in the transmission network? Thank you.
Maybe some trouble in author. I think author will answer you in chat, but we must go on, and the next presentation is on the topic method of operative determination of the stability of circulating water in regard to the release of calcium SO3. I see the author, and we can start.
Method of operational determination of circulating water stability relating to the release of calcium carbonate. National University of Water and Environmental Engineering, Ukraine. Volodymyr Kuchmarsky, Viktor Mashinsky. Due to the evaporation of water and the associated concentration of salt, circulating water supply systems have specific disadvantages. See description below. The research finding on the composition of deposits on the pipe system of turbine condensers, according to the data of 22 large thermal power plants, are presented in Figure 2. The main part of the deposits is made up of calcium carbonate with 37%. Magnesium carbonate compounds make up less than 2% of the total. Organic compounds with about 7% are second in mass composition. The solubility of magnesium carbonate is approximately 1,350 times higher than the solubility of calcium carbonate. Therefore, the concentration of magnesium increases in the circulating water supply system by a multiple of the evaporation coefficient and becomes comparable with the concentration of calcium. The discrepancies at the beginning and at the end of the measurements are explained by the error in determining the magnesium concentration, since Ca magnesium more than Ca chloride, which is impossible. Existing method to determine the circulating water stability. To determine the circulating water stability relating to the release of calcium carbonate, there are supersaturation indices for calcium carbonate or the Langelier saturation index used. Unfortunately, both indices do not quantify the degree of hydrocarbonate system deviation from the equilibrium. Nuclear power plants also use the relation presented in Formula 1. The description of the formula is given below. Therefore, at present, there is no quantitative method for determining the degree of stability of circulating water that can be used to control deposits. Part 3. Operative control of circulating water stability. It is impossible to control the process of circulating water stability without monitoring its effectiveness. Classic method implies the use of special inserts witnesses in the tubes of heat exchangers which determine the amount of deposits. Technological control of circulating water stability at power plants is also carried out by vacuum and temperature difference in the turbine condensers. In addition, information about the vacuum is received belatedly, and this does not allow for operational measure to control deposits. Circulating water stability index. It is determined from the equation of the dynamics of the calcium ions concentration in the circulating water supply systems, which is transformed to the form see Formula 2. In Formula 3, dashes over C calcium T and C calcium carbonate T corresponds to the time derivatives of the corresponding values. Psi St is the concentration of calcium ions in the circulating water, referred to a would-be concentration in the circulating water under the absence of calcium carbonate release. The value of Psi St will be considered the stability index under slow changes in the calcium ions concentration in the circulation water. The parameter phi is calculated according to a special procedure, but it could approximately be taken equal to the evaporation coefficient. So the stability index is presented in Formula 4. The release rate of calcium carbonate is calculated by Formula 5. We emphasize that formulas 4 and 5 allow determining the degree of water stability both qualitatively and quantitatively. Part 4. applying stability index in real circulating systems. Let us calculate the dose of sulfuric acid that must be added to the feed water in order to obtain circulating water supply system stability of maximum Psi-ST. Let us take into account that each gram ion on the acid binds an equivalent amount of calcium ions, and the formula for the desired value of the stability index will be as follows. See Formula 6, description below. From Formula 6, we find the required acid concentration millimole per cubic decimeters. See Formula 7. Taking into account that due to evaporation the acid concentration in the circulating water is Phi times higher than in the makeup water, we find the calculating formula for the acid concentration in the makeup water. See Formula 8. Example of the calculation, see below. Improving the circulating water stability with bypassing. Let us consider the application of the stability index to the circulating water supply system of one of the Donbas power plants. A feature of this circulating water supply system was the use of bypass clarification of the circulating water. To increase the stability of the ongoing Psi-ST approximately 0.6, see figure 4. Starting from the 300th day of observation, bypass clarification of the circulating water is carried out. Figure 4 shows that the use of circulated water bypass clarification increases the stability of the circulating water to 87% while maintaining the same inhibitors concentration of 3.5 milligrams per cubic decimeter. After reaching Psi-ST approximately 0.82-0.88, the deposition rate decreased almost 3 times. In order to verify the adequacy of algorithm for calculating the degree of stability, starting from the 540th day, the inhibitor's dose was reduced by 30%, while the calculated stability also decreased by 30%. This indicates that the method of calculating the stability index of circulating water adequately reflects the processes in circulating water. In order to verify the adequacy of representation by the stability index of the process in the circulating water, we compared the dynamics of the inhibitors concentration in the circulating water at the Rivne nuclear power plant and the calculated value of the stability index. The result is shown in figure 5, representing a good correlation between both values. We should note that circulating water stability increased due to the dosing of the acid at the beginning and at the end of the measurements. Conclusions. First, Formula 4 was obtained for circulating water stability index that allows calculating the value of circulating water stability. Formula 5 shows that the calcium carbonate release rate depends on the makeup of water consumptions. The second, for operational monitoring of the effectiveness of scale inhibitors, it is necessary to regularly measure the parameters of water quality and the circulating water supply system operation mode and temperature of circulating water. It is desirable to make measurement with automatic registration and data storage. The third, it is necessary to amend the regulatory documents in terms of measures to stabilize circulating water and assess its sustainability. See paragraph 2 of the conclusion. The list of constantly monitored circulating water parameters according to paragraph 2 needs to be added to the regulatory documents as well. Thank you for your attention.
Thank you for your presentation. Dear colleagues, have any question? If any question, I have a short question. What can you tell you about the future development of your research?
Справа в тому, я можу по-українськи?
Ну, спробуйте, я перекладу коротко. Тоді коротко дуже.
На всіх теплових, атомних і на великих підприємствах, де використовуються охолоджувальні системи потужні, виникають ці проблеми відкладень, і ми пропонуємо швидкий оперативний метод визначення стану і, відповідно, боротьби з цими відкладеннями.
Thank you. The answer was that colleagues developed the method for the lower influence of carbonate sources on the thermoelectric plants and atomic plants. And because in this field there are many problems which connect with this research. So according to the program, we must go on, and the next presentation is on the topic contradiction in electric power sector development Ukraine versus EU. I see the present authors and we can start.
Hello, everyone. First of all, we are very thankful for you to take part in this conference. I am Tatiana Salashenko, candidate of Economic Sciences, Senior Research Fellow, and my co-author is Doctor of Economic Sciences, Professor Victoria Kauster. I represent a Research Center for Industrial Problems of Development, National Academy of Sciences of Ukraine. And today, let us present the results of our research, Contradictions in Electric Power Sector Development, Ukraine versus EU. Ukraine strives to be the full member of European Union and to integrate into the European energy space. And nowadays, it achieved such results. It has been a member of energy community since 2010. It implemented the pro-European model of electricity market since the mid of 2019. Has been synchronized electric power system with the entire European one since the February 24th of 2022, and has become an observer member of IntelCE since the March 16th of 2022. And 23rd of June 2022, the European Council granted Ukraine the status of candidate of accession to the European Union. Nevertheless, that now the Ukrainian electric power grids technically fulfill the European rules, its electric power sector remains still outdated and its development is not following European trends. The problem of electric power sector development has been strongly exacerbated by the Russian invasion of Ukraine. Currently, it is impossible to analyze the damage of electric power sector due to cybersecurity requirements. However, by the calculations of BBC, the Ukrainian electric power system suffered more than 250 strikes. To rebuild the electric power sector after the war, according to the European pillars, without neglecting national interests, it is needed to explore Ukrainian previous experience. So, the aim of the research is to develop methodological support for the analysis of input-output electricity flows and compare key trends in the electric power sector development in Ukraine with EU common ones. Such comparative analysis of input-output electricity flow in Ukraine and the EU can be carried out on the basis of Sankey diagrams, which are possible to build using Microsoft Power BI software. The data set of the research is a Eurostat database that ensures the unification and comparability of data by the dimension of the electric power system, energy sources, and types of activity. Constructed input-output model of electricity flows is depicted on this slide. Based on this model, it is possible to determine qualitative indicators of the electric power sector development, which can be divided into 3 groups: energy efficient, structural, and security and integration indicators. All these indicators can also be calculated in the Power BI software space using measures. On the next 2 slides, you can see constructed Sankey charts for the EU and Ukraine electric power system and see their differences. And I'm going to stop exactly on the contradictions of the European and Ukrainian electric power sector development. The first one, above all in the EU, the decarbonization of the electric power sector. Firstly, there was a shift towards nuclear energy, but later the share of nuclear energy, considering the events at the Fukushima Daiichi, returned to the previous level. Decarbonization also occurred due to the deployment of gas-fired electricity generation. That was due to its higher energy efficiency and climate friendliness. But later, gas-fired power generation plays a role of supporting renewable generation. The active deployment of unconventional renewable generation began in the 2000s, starting with wind and biofuels. In 2020, the total share of all types of unconventional renewables power generation reached 20%. Thus, the structure of EU power generation accounted for 60% of low-carbon energy sources. Compared to the EU, the first one, Ukrainian trend, can be stated as gas-to-coal switching. The gas-fired power generation in Ukraine, after a slight increase in 1990s, gradually decreased after 2000, aiming to decline the gas dependency of Ukraine. The share of nuclear heat in power generation has been constantly growing up, but in absolute terms, it remained approximately the same. Among the unconventional renewables, the greatest growth was reached by solar energy. Therefore, Ukraine is forced to abandon the more climate-friendly gas-fired power generation and support dirty power generation based on the solid fossil fuels at the sufficient level, and also limit hydropower generation for the deployment, especially solar and also wind power generation. This phenomenon nowadays is known as green coal. The first trend is strongly connected to the second one, which is deployment of highly efficient cogeneration in the EU. In general, the development of cogeneration is considered a way to reduce the useful losses of the electric power sector imposed by technological limitation of electricity-only generation. Technological changes made it possible to increase the energy efficiency of cogeneration from 55% in 1991 to 63% in 2020. There were also structural shifts towards an increase the share of power generation in gross output of cogeneration on 40% in absolute terms. In contradiction to the EU, the second Ukrainian trend is reducing the volumes and energy efficiency of cogeneration due to the lack of sufficient district heating demand in the CHP-related territories. The energy efficiency of cogeneration in Ukraine decreased to 68% in 2020 and was associated with a decrease in the heat share in gross output and also the physical obsolescence. The third trend is increasing the energy efficiency of the electric power sector at all stages in the EU. Firstly, this happened due to the deployment of renewables. Secondly, there was also an increase in the energy efficiency of gas-fired generation. At the same time, a technological and commercial limitation restricted changes in the energy efficiency of nuclear and solid fuel generation. Increasing the energy efficiency of power generation can be also confirmed by the increasing net output from gross power generation. But the electricity losses in the grids were increased up to 13% in 2020. The above mentioned led to the general energy efficiency increase of the European electric power sector from 29% in 1991 to 40% in 2020. At the same time, stable too low energy efficiency alienates the Ukrainian electric power sector from the European common one. The energy efficiency of electricity-only generation increased only by 3% up to 36% in 2020. This was largely made by the deployment of renewables as well as reconstruction of several coal-fired steam turbine power units. At the same time, the Ukrainian power generation is physically and morally obsolete, which also led to significant electricity for the own use for power plants. The physical outdated and lack of modernization of power grids also led to high electricity losses through its transmission and distribution. However, the share of electricity losses steadily decreased from 13% in 1991 to 9% in 2020. In general, the energy efficiency of Ukrainian electric power sector accounted for 26% in 2020 and increased only by 3% compared to 1991. Decentralization is a fourth trend of the European electric power sector development. The causes of growth of transportation electricity losses are straightly associated with increasing electricity flows through distribution grids, which a priori have larger losses against transmission ones. This trend can also be confirmed by the increasing share of after-producer in the total European power generation. Thus, more and more European consumers aimed at being prosumers and self-providing their own electricity needs. At the same time, Ukrainian electric power sector is Soviet heritage of a centralized type. Since the independence of Ukraine, only transmission grids have undergone upgrades to synchronize this into SE, while distribution ones remain absolute. This fact is associated with a decrease in transportation losses. The deindustrialization of Ukraine has led to a greater centralization of electric power sector by the closure of a number of after-producers of electricity. The fifth trend is opening the boundaries of the national electricity markets of the EU member states and increasing their electricity dependency. The development of market treatment, deployment of renewables, and desire to create a single market space on and beyond EU initiated the growth of external electricity flows. Thus, the import and export of electricity more than doubled in 1991-2020. Subsequently, the self-sufficiency of the EU electric power sector decreased to 93%. At the same time, Ukrainian electric power sector has been and remains self-sufficient, and net power generation has always exceeded consumer needs. Currently, Ukraine has limited opportunities for electricity trading with neighboring countries. So, in 2020, import dependency increased only up to 2%, while export dependency was at 4%. Awareness of the value of electricity in modern society forms sixth trend in the EU. Its penetration in all spheres of economy. There had been made significant structural shifts in the final electricity consumption. Firstly, these shifts were associated with responsible electricity consumption, and secondly, with the plateau of industrial electricity consumption. At the same time, the improvement of quality of life led to increasing electricity consumption by the services and households. Therefore, it can be admitted the ongoing convergence of the shares of the three types of activity: industry, services, and households. At the same time, the industrialization of the Ukrainian economy alters electricity consumption patterns. The falling industrial production led to a reduction in industrial electricity consumption by 76% in studied period. Notwithstanding the social economic condition, households and services increased electricity consumption all time, and even the loss and occupation of part of the territories of Ukraine led to a slight reduction in their electricity consumption. Consequently, in 2020, the total share of non-commercial electricity consumption in Ukraine exceeded the share of commercial electricity consumption by 6%. Although in 1991, this ratio were reversed, exceeded 4 times. So on the last slide, you can see the general conclusions of the contradictions between Ukraine and European electric power sector development and some proposals to overcome them. In general, it should be noted that although Ukraine strives to adhere to European trends of the deployment of renewable electric power generation, however, other trends were contradictory, intensive shifts were insignificant, and were complicated by the physical and moral obsolescence of electric power sector. And thank you for your attention. I will be glad to answer your question.
For your presentation, maybe some question.
I have question.
You are welcome.
Yeah.
One of the promission direction of energy development in the world is the development and implementation of small modular reactor in the future. Do you consider this information in your research? Thank you.
I'm sorry, small developments, small what? Plants?
Small modular reactors.
Yes, yes.
Small modular reactors. Yeah, small modular nuclear reactors. This is a new trend of years ago. This trend was not so prominent, but nowadays I think that such small modular nuclear reactors can help. First of all, decentralize our electric power system. The second one, it's help to interconnect it with European countries. But nowadays, there is small perspective for develop them in Ukraine, I mean, not in the EU, because we have two projects to build two nuclear reactors in Khmelnytsk nuclear power plant that are currently not finished. So we must focus on this purpose, first of all, and then try to elaborate our nuclear strategy to develop our electric power system, because to decentralize it, such small modular nuclear reactors must be in every sub-region of the entire electric power system. That is my opinion.
Thank you very much. Any other question, please? I don't see other question.
Can I?
You are welcome.
This is not my question. This must be a question from Professor Sauch. What do you think? Do we need, after the war, some market instruments to push our development of power energy to European distributed method, for example, large distribution of local generation?
Thank you for your question. First of all, my answer will be, since the mid-2019, we only implemented electricity energy-only market in the electricity-only model. We have no capacity remuneration mechanism. We have no green auction in Ukraine. So to recover our electric power system, first of all, we must implement such market mechanism to attract investments in our electric power system. They must be transparent and develop on the European rules. to recover our electric power system.
Thank you so much.
Thank you.
Any other question? No question. So move on. And the next presentation, I see the author, approximation mathematical model on an absorption heat pump with steam heating for integration in the steam turbine thermal scheme. Let's start.
Hello, my name is Alexander. For your attention, a report of the topic approximation mathematical model of an absorption heat pump with steam heating for integration in the steam turbine thermal scheme is of rate. Currently, much attention is paid to energy saving through the introduction of energy efficient technical solutions in the heat and electricity production. One of a solution to improve the efficiency of heat and electricity production at cogeneration heat power plants is the implementation of heat pump for depending utilization of the burned fuel heat. To solve the problem at the first stage, it's necessary to improve the mathematical model for calculating thermal processes in power plants. In this regard, the main task of this stage follows. The aim to develop a finally simple approximation mathematical model of steam heated AHP based on the characteristics of manufacturers of real thermal transformators and applicable in solving problems of its integration. To investigate the level of changes in the material flows of the powerful steam turbine with an integration absorption heat pump with steam heating during the heating season. And tasks are presented also in this slide. For further modeling of AHP, the technical characteristics of powerful AHP of Broad Corporation were analyzed. In this case, consider the standard characteristics of AHP in terms of standard pressure losses in heat carriers, flow rate of heat carriers, and electric energy. Interpolation dependence is also presented for determining the relative thermal power of AHP, which depends on the temperature of the chilled water after the pump, the temperature of water that is heated, inlet and outlet. The dependencies on the nomogram are linear. To approximate each of the 4 straight lines on the right side of the nomogram and 5 on the left, it is enough to specify the coordinates of 2 points based on these conditions. The base point were interpolated using a one-dimension spline. The calculation is carried out using a set software package developed by the Anatoly Pedgora Institute of Mechanical Engineering Problems, NASA of Ukraine. It is based on a set of balance equations when constructing a heat scheme in the form of components and connections between them. This software package has been improved by adding algorithm for determining AHP indicators using approximation dependencies, factory characteristics, and consideration equations. Accordingly, this component of the software package is characterized by the presence of initial date and determined characteristics. This algorithm served as the basis for creating software models for determining the characteristics of AHP and its subsequent integration into the turbogeneration thermal scheme. The scale and importance of solving the problem of integrating EHP into the thermal schemes of powerful cogeneration plants is evidence by the general characteristics of the existing cogeneration heat power plants on the territory of Ukraine. The analysis carried out shows that turbines of PT60 type are mostly widely used. Also, for comparison and further computational studies, the outdoor temperature are given according to this tool for the region where PT60 turbine plants are located. The scheme of EHP integration into PT60 thermal scheme, the future of which is the presence of only one extraction for steam supply for heating, is shown in this figure. As can be seen from this scheme, the steam of the heating EHP is taken from the regulated production extraction PT60, operating at a pressure 1.3 megapascal. The pump is heated by steam with a pressure of 0.474 megapascal coming from the exhaust of an additional steam turbine with a back pressure. It was installed for the purpose of energy saving. The features of the mathematical model of PT60 thermal scheme associated with the desire of bring the result of calculation closer to the real ones include the use of the factory approximation dependence power of lower pressure path from the flow rate of low pressure path. The processes of steam expansion in the flow path of PT60 turbine in the ES diagram with the RCD closed is shown the solid line on figure. When EHP is integrated, in many cases of pressure in condenser, the steam flow to the condenser increases and heat drop is used in the low pressure part. Characteristics of PT60 thermal scheme at average monthly loading modes with integrated EHP 24 megapascal while providing heat supply and supply for production extraction 80 tons per hour of steam. Power of a small steam turbine with a back pressure more than 1 megawatt. The results are presented for each month in the heating season on these slides. This slide and this slide. Calculation of the change in the performance of PT60 turbine unit after the integration EHP into the thermal scheme is presented in this table. To determine the change in the amount of harmful emissions of CO2 and NOx into the atmosphere, we used experience. When burning 1 ton of natural gas, the following amount of harmful emission is formed: CO2 equal to 0.726 tons per ton and NOx equal 0.0143 tons per ton. The data in this table are shown. When EHP is integrated, the consumption of fuel and the technical water for feeding of the circulation system has a steady downward trend. The difference in the volumes of electric power generation with integrating EHP into PT60 from the non-integrated is depends on the operating mode. PT60 modes without a heat pump, where big hot water boiler works, allows in integration. The conclusions are presented on this slide, but in the end, I would like to note that the realization of absorption heat pump at powerful cogeneration heat power plant will save fuel resources and reduce the harmful impact in the environment during the heat and electricity generation. Thank you for your attention.
Good day to everyone in the conference. Today.
Thank you for your presentation. Dear colleagues, any question, please?
I have one.
You are welcome.
The title of your presentation, the first three words, approximative mathematical model. What does it mean, approximative, in this context?
We use different characteristics of absorption heat pump, which produce in manufacturers, and we use these characteristics for our calculation in next research.
I have only one comment or one remark exactly to this expression in the title. Mathematical model itself means approximation of the physical processes or physical features and approximative approximation model. It's doesn't correct title, and I think that the word approximative must be excluded in the title and simply mathematical model and continue.
We have.
Thank you.
Thank for your comments, but we have mathematical model of powerful turbines, and this approximation we will use in our next study with complex work of powerful turbine and absorption heat pump.
Okay, thank you, dear colleagues. We must move on, and the next presentation, I see author is here, is the fuzzy logic in the decision-making task of connecting renewable energy sources into the electricity supply system. Let's start.
Good day to everyone in the conference. Today we would like to present the results of our research on fuzzy logic in the decision-making tasks of connecting renewable energy sources into the electricity supply system. In the current geopolitical context, environmental damage, depletion of fossil fuels, and territorial imbalances are factors that require a change in the energy mix, and the introduction of measures to invest in energy diversification and the integration of renewable energy sources. According to a report by the International Renewable Energy Agency, 3,064 gigawatts of renewable generation capacity was in operation worldwide at the end of 2021. Of this volume, 40% is accounted for by hydroelectric power plants, 28% by solar power plants, and 27% by wind power plants. However, if we look at the dynamics of capacity growth in recent years, solar and wind power dominate the expansion of renewable energy capacities. In Ukraine, the total capacity of renewable energy facilities reached 16.9 gigawatts as of the end of 2021. In Ukraine, the market is growing mainly due to domestic and commercial solar power plants for self-consumption. However, in recent years, there has been a significant increase in distributed generation, the bulk of which is accounted for by home solar power plants that have received a feed-in tariff. The generation of electricity by wind and solar power plants is probabilistic. When elements whose behavior is difficult to predict are added to the power grid, maintaining a balance of power in the system becomes more challenging. This becomes more noticeable as the penetration of these renewable sources increases. In addition, their stochastic nature of production has a significant impact on the deviation of power quality indicators. Therefore, decision-making on the integration of renewable energy sources into the power supply system should be based on an analysis of the modes and processes that arise under different options for connecting renewable energy sources. Thus, there is a new scientific and technical problem of ensuring the effective integration of renewable energy sources into the power supply system. In order to assess and compare possible problems at the level of transmission and distribution system operators as a result of renewable energy sources connection to the electricity supply system, it is advisable to introduce the concept of risk. Considering the problem under study, the risk profile can be formed according to the scheme shown on the screen. The proposed algorithm analyzes the existing system parameters at the first stage. The second stage is based on analyzing, identifying, and assessing risks, including using information technology. The main goal and end result of this stage is to formalize the risk profile of renewable energy sources integration, since any risk management system is based on the process of risk profiling. In a real-world model, there is always a technological spread of parameters due to the complexity of the system. To solve this problem, it is proposed to use a fuzzy logic model. Among the many indicators, the following parameters can be used as primary risk indicators: indicators of electricity quality at the boundary of balance of ownership between the distribution system operator and the consumer, characteristics of the electricity supply voltage and their normalized values, indicators of electricity supply reliability. Based on the expert data obtained in the previous study, the following indicators will be used for further analysis: the occurrence of higher harmonics, voltage deviation, and reactive power flow. The occurrence of higher harmonics was defined by an ordered term set of values consisting of 3 terms: low, medium, and high. The terms are listed in order from the most negative to the most positive. In accordance with the tasks set, it is enough to select 3 linguistic variables to describe the aspects of the factor for further application of the fuzzy logic method. This scale is also used for other indicators. The MATLAB module includes 11 built-in membership types. However, in practice, it is convenient to use those membership functions that allow an analytical representation in the form of some simple mathematical function. This simplifies not only the corresponding numerical calculations, but also reduces computing resources. Therefore, in our study, we considered triangular, trapezoidal, and simple Gaussian membership functions. The slide shows the analytical writing of the triangular function. The parameters a and c characterize the base of the triangle, and the parameter b characterizes its vertex. The following is a trapezoidal membership function. Parameters a and d characterize the lower base of the trapezoid, and parameters b and c characterize the upper base of the trapezoid. A commonly used method of generating a membership function is to use a Gaussian curve. Based on the Gaussian distribution function, 2 types of membership functions can be constructed: a simple Gaussian membership function and a bilateral membership function formed using different Gaussian distribution functions. In this expression, c is the coordinate of the maximum of the membership function, and sigma is the concentration coefficient of the membership function. The accuracy of risk assessment in the integration of renewable energy sources depends on the completeness of the knowledge base. The flexibility of the analysis process is achieved by setting key decision-making rules. Considering the relevant possibility of occurrence and the level of consequence from the implementation of factors, the results of building fuzzy logic are obtained. In this case, they are based on the identified 27 rules. To analyze the results of the model, it is necessary to make a graphical interpretation of the rules, which will make it possible to see how the model works for the 3 output parameters. According to the results, the degree of integration for the same values of the system parameters for the 3 selected membership functions is within a small range of deviations. A small range of deviations indicates the adequacy of the developed model. The MATLAB functionality makes it possible to view the input-output surface corresponding to the synthesized fuzzy system. However, when we go beyond the 3 dimensions, we begin to face problems with the full display of the results. Since our system has 3 inputs and 1 output, the program can only generate a 3-dimensional output surface where any 2 inputs change, but one of the inputs must remain constant. When using this tool, you can model various connection options based on logical rules. The data obtained can then be used to set requirements for the parameters of the electrical installation at the stage of issuing technical specifications to the customer. The fuzzy inference surface makes it possible to visually assess the probabilities of a situation that may result from the connection of a particular renewable energy sources installation. In order to obtain the highest efficiency of renewable energy sources, it is necessary to adhere to the parameters that form the yellow and green zones of the profile. The blue zone, on the contrary, is characterized by the greatest risks to the normal functioning of the system, and shows a categorically unacceptable integration of the system and renewable energy sources under these parameters. Getting into the blue zone is also not recommended, as there is low efficiency from renewable energy sources and a higher probability of risk consequences. The graphs have a local decrease in the level of integration, which is explained by the number of logical variables and rules. With their increase, the model will more accurately reflect the level of integration for making decisions on renewable energy sources connection, which will be done in further research. The rapid development of renewable energy is taking place without taking into account the real needs of Ukraine's energy system for additional generating capacity. This can lead to destabilization of the country's power system and the possibility of emergencies. In the tasks of risk assessment when connecting renewable energy sources and decision-making under uncertainty, there are problems that are difficult to solve using traditional methods. To solve this problem, it is necessary to use the mathematical apparatus of fuzzy logic theory. We have developed a fuzzy model for risk assessment in the integration of residential into the power supply system based on expert data. To formalize the initial data, we use triangular, trapezoidal, and simple Gaussian membership functions for the input variables. According to the results, the degree of integration at the same values of the system parameters for the 3 selected membership functions is in a small range of deviations, which indicates the adequacy of the developed model. In the future, it can be supplemented or modified by an expert by introducing other rules, adjusting membership functions for variables, and adding new parameters. The use of fuzzy logic allows tracking the degree of risk of renewable energy sources integration at different values of system parameters. When applying this toolkit, different connection options can be modeled based on logical rules, and then the data obtained can be used to set requirements for the parameters of the electrical installation at the stage of issuing technical specifications to the customer. Thank you for your attention. If you have any questions, we will be happy to answer them.
Thank you for your presentation. Dear colleagues, any question? Yes, Ali, you're welcome.
Despite very interesting theme and methods represented, my question is, please tell who was representing this presentation? Who was the narrator?
No, the narrator was by machine sounds.
I should mention this, and I ask our chair to mention this. We were listening to the machine. Thank you.
Yes, any question, please? Yes,
I have one. It is well known that the renewable generation power, such as wind or solar power plant, characterizes the high level of uncertainty and maneuverable of this or production of the energy. And it is very difficult to penetrate this technology in the electricity power system because maneuverable and uncontrollable and variability and unpredictability of the producers, this technology does not control. It's a negative influence on the stability of the power system. What these factors or features of the renewable sources take into account in the model you are proposed?
Okay, thank you for the question. Yes, we have model for three parameters like higher harmonics, voltage deviation, and reactive power flow. But we scale for evaluation of indicators, and then we want to develop a methodology for the control and efficient development of this type of energy. So we can then determine the relevant requirements for these parameters. Now it's like a model to show that the impact of renewable energy on energy system.
Does it mean that you investigate the process of the penetration of renewable resources in the system separately, not include into account the power system as a whole?
No, one moment please, we have factors and we take expert opinion from 10 members from different areas, and then they choose exhaust these factors.
And who was the experts?
Oh, sorry, now I cannot remember them. This topic of my scientist.
Thank you.
Thank you, dear colleagues. I see in chat we have answer on the question which will to the 18 presentation. Thank you, Alexander Plachty, for the answer. And now we move on, and the next presentation is the influence of electric transportation charging model on the operation of the Ukrainian integrated electricity system and emission levels. I see the author, and we can start.
Hello, everyone. I'm glad to warmly greet the organizers and participants of the conference. The topic of my presentation addresses urgent issues of sustainable energy and transportation development. Nowadays, humanity is seriously concerned about the problem of global warming and local environmental pollution. Transportation is one of the economic sectors that is facing serious challenges due to environmental concerns. These concerns include the combustion of fossil fuels, global warming, and local pollution. Implementation of battery-powered electric vehicles could be an effective solution to mitigate environmental issues and reduce fossil fuel consumption. The fleet of electric transportation rapidly increases worldwide. Now, Ukrainian government is planning to develop national strategy and programs for electric transportation implementation. The common practice is to compare emissions from electric vehicles with petrol cars, using average consumption of electricity fuel per 1 kilometer and specific emissions of greenhouse gases and pollutants from electricity use. This approach is not comprehensive. I'd like to look at the problem from another side. We should take into account that electric vehicles charging is additional load on energy system operation. Therefore, electric transportation causes changes in energy system functioning and consequently changes in the emission level. Therefore, the fundamental study of the influence of electric transportation implementation on the Ukrainian integrated power system is needed for developing strategies of electric vehicle fleet increase. The experience of other countries is not applicable for Ukrainian circumstances. The Ukrainian power system is a unique, complex system with different energy sources, partly obsolete equipment, etc. The main factors to consider are the volume of electric vehicles and electric vehicles charging model. The specific feature of electric transportation is the opportunity to vary the charging load during the day due to implementing different regulatory and/or incentive measures. The aim of the study is to estimate the effect of different electric transportation charging models on the Ukrainian integrated power system operation, fossil fuel consumption, greenhouse gases, and pollutant emissions. The study was carried out for the pre-war state of the integrated power system. The distribution of energy sources in pre-war period are shown in the slide. Nuclear energy provides a reliable base load and covers more than half of electricity production in the Ukraine. There are 4 nuclear power plants with 15 reactors in total. There were 12 thermal power plants in Ukraine. Most TTPs are using coal as a primary fuel. Hydropower plays a crucial role in the functioning of the Ukrainian power system, as they are main providers of auxiliary services to meet the peak demand of the power system and balance intermittent. Renewable energy sources also contribute to flattening the night gaps of electricity consumption. Now, energy system has suffered huge damage due to the war with Russian Federation. Nevertheless, the IPS will definitely be restored and updated in the post-war period. It should be expected nuclear and hydropower will recover to the same extent. TPPs are likely to be equipped with new generation equipment and exhaust gas purification systems. At the same time, the IPS operation characteristics, specific fuel consumption, and emission factors will change. In such case, it's necessary to recalculate relevant values. I used the software complex simulating the operation of Ukrainian integrated power system developed in the General Energy Institute of the National Academy of Sciences of Ukraine. This complex is based on non-linear mixed integer least cost dispatch model. It contains information of all power units in the Ukrainian integrated power system. A set of calculations was carried out for assessing influence of electric transportation charging models on Ukrainian energy system functioning, fuel consumption, and emissions of carbon dioxide and pollutants. 4 scenarios were considered. First scenario assumes the electric vehicle fleet at the 2020 level, baseline. Next 3 scenarios assume that the number of electric vehicles in Ukraine increased by 5 times and consider 3 charging models, standard, equal, and 9. Evidently, 2 last models are ideal and not achievable really. However, the results indicate the direction for development of strategy and regulatory acts to get better results. Diagrams of this slide illustrate structure of Ukrainian energy system operation under 4 scenarios in January, July, and Enyo. I chose January and July because usually these months differ each other significantly in consumption level, as well as wind, solar, and hydro characteristics. The results show that the share of nuclear power plants increases practically for all scenarios except for the scenario X5 equal in winter. Therefore, it's expected the decrease of fuel consumption as well as GG and pollutants emissions. The table at the slide illustrates this fact. The figures in the slide show the behavior of fuel intensity and carbon dioxide emissions throughout the year. Fuel intensity increases in winter for all scenarios because the share of electric vehicle load is smaller than in the summer. In summer and annually, the decrease of fuel intensity and emissions reaches up to approximately 14% X5-9. For scenario X5 equal, GG and pollutant emissions increase despite of decrease of fuel intensity. This is explained by the larger share of coal thermal power plants compared to gas thermal power plants. It should be noted that such trends are observed exclusively for Ukraine due to specific structure of Ukraine with large share of nuclear energy. Electric transportation volumes rapidly increase around the world. Ukrainian government also plans to develop strategies for electric transportation implementation. For these purposes, it's necessary to study their influence as additional load on Ukrainian integrated power system operation. This study analyzes the influence of electric transportation charging models on fuel consumed by energy system, fuel intensity, and emission levels. The calculations were carried out using software complex developed in the General Energy Institute. 3 charging models were considered, specifically standard, night, and equal. Evidently, 2 last models are ideal and not achievable really. However, the results indicate the direction for development of strategy and regulatory acts to get better results. Thank you for your attention. I will be happy to answer any questions that might appear.
Thank you for your presentation, dear colleagues. Do you have any question?
I have a remark.
You are welcome.
Thank you. On the slide named national circumstance, on the left side, left part of this side, you show the installed capacity.
Yes.
In percent, but it's not correct information. Installed capacity, for example, nuclear power is significantly smaller than thermal part. And you show this information based on the production volume of the electricity, does not install capacity. Please correct this information. Thank you.
Thank you.
Thank you for your comment. Any other question, please? So I have a very short question. How you think electrical transport in the future can less the level of emission, and how it influence to the emission level?
The introduction or implementation of electric transportation is additional load on integrated power system of Ukraine. And due to the large share of nuclear power plants in the Ukraine, additional load will lead to the increasing of nuclear power production. And so the emission of greenhouse gases, the volume of fuel and the emissions of greenhouse gas emissions and pollutants will be decreased.
Mm-hmm. Thank you very much. Any other question? I don't see. Thank you for your presentation, and move on. The next presentation And is the last presentation in our session on the topic automatic method for preparing of data for setting the model of electric network model when constructing the mnemonic diagram of the object for simulation. I see the author and we can start.
Good afternoon. My name is Anton Lipativ, and I represent G.E. Pukov Institute for Modeling in Energy Engineering, and topic of my report is automatic method of preparation of data for setting the model of the electric network mode when constructing the mnemonic diagram of the object for the simulator. Object of the research is training tasks for distribution network personnel. Purpose of the research is the creating the method that reduce the time for developing a simulator task. And it is necessary to speed up the process of developing simulator tests because of account of innovation in the energy sector. And subject of the research is program distribution network model. This is program that was created using a graphical editor that contains a graphic field and a library of distribution network components, with which it is possible to create a mnemonic diagram model that will completely duplicate the existing distribution network. The model can be run on any device with a Windows operation system, which is beneficial from an economic point of view. The model of distribution network mode does not require the presence of a programmer at the task development stage, since all the processes that requires the programmer work, such as calculation of current or voltage values, mode switching, functions of distribution network components, were done before the task development stage. Why training in the energy industry is so important? Rapid advances in technology have also affected the energy industry. In the components of energy distribution network, characteristics and properties change dynamically, and the network themselves undergo frequent changes in the number of components and structural changes. On the figure, you can see an examples of new electrical power components. Given those changes, employees need to learn new knowledge and test current skills. The lack of skills and lack of qualification of personnel in this area threatens the safety of people as a failure of networks. Let's take a look at the process of constructing a training task before implementing the method. The process consists of 5 stages. The first 3 stages are made by developer, as you can see by human icon at the top left of these stages. 2 are performed programmatically. At stage number 3, setting structural parameters, initially the developer manually enters the structural parameters, such as number of copies of component branch indices. The main disadvantage of this method of preparing mode model settings data is the possibility of errors when entering this data. These errors can occur if the task developer copied a ready-made parameter, pasted it, but forgot to change the value to the required one. Therefore, several parameters will have the same values of node numbers or branch indices, which will lead to an error in calculation of the mode values. It can take a long time to find invalid parameter values because developer needs to check every component that he placed before. An error in the conclusion of modes makes this training task irrelevant in the process of training the personnel of the distribution network, which leads to a decrease in the competence of the personnel. Therefore, it was decided to develop a new data entry method that would eliminate the human factor in the process of entering structural parameters. This method has been called the automatic data entry method for setting up the mode model. First change that this method brought is structured data is setting automatically, which means it does not require developer implementing during this stage. Unlike manual preparation, in automatic preparation, a copy of the node components received its number in the process of adding it to the mnemonic diagram. The service task of preparing structural parameters consists of 3 cycles. In each of the cycles, structural parameters are assigned to the copies of components. While browsing all the components, the array of components is filled. After the array is filled, it loops over it. Second change is a new structural component connection that was added to mnemonic diagram component library. The connection component performs the function of transferring the structure parameter from node or branch copies to voltage or current output components copies. When constructing a mnemonic diagram, as you can see on the left figure, copy of the connection component must be placed so that one end of the line enters the node or branch, and another must enter the intents of the voltage or current output. And the last change is components double winning transformer and 3 winning transformer have been changed. When the mnemonic diagram components were transferred from manual to automatic data preparation, the double winning transformer and 3 winning transformer components had a problem with assigning a number to the transformer nodes and assigning the index to the transformer branches. This issue has been fixed by adding transformer nodes and transformer branches inside transformer components copies. Also, transformers branches are not visible on mnemonic diagram as they located the inner layer of the transformer, which is as shown on middle and right figures. Let's take a look at the process of constructing a training task after implementing the automatic method. The number of stages decreased to 4. Settings of structure parameters now happen after start of the program, and in the same stage as setting links. The time to create a training task is reduced by almost 20%. Such a small, at first glance, decrease is explained by an increase in the number of copies of the mnemonic diagram due to the new component connection. Number of errors made during creation of training tasks is reduced by 68%, which shows how often the developers made mistakes during this stage of filling in the structural parameters. The average time to find and correct an error is reduced by 43%. This shows that the errors that are made after implementing the automatic method are visibly more noticeable and can be corrected much faster. And automatic method of preparation of data for setting the model can be improved by reducing the number of cycles that go through all copies of the mnemonic diagram model from 3 cycles to 1 cycle. Thank you for your attention.
Thank you for your presentation. Dear colleagues, do you have any question?
Dear committee, could I please ask one question?
Yes.
Could you please describe how did you check the adequacy of your model?
The voltage and current values are shown on the components that shows, and how is correct, how to check the correct of the model. Yes. So you could ask a person that that understands how net distribution networks work, and ask him is the values are correct. And also you can check on other simulators the values of current and voltage.
Thank you.
Thank you, dear colleagues. Any other question, please? So I have a short question. In our previous research, you used a UML diagram, but now I see you are using a BPMN diagram. Why? Is the BPMN diagram better for your research?
Actually, I use also BPN diagram in article. So it's also in article, and I change a little bit. I numeric stages for better understanding how many stages of this. But I still on article use the BPN too standard. So nothing changed in this aspect. It's like same standard.
Okay, thank you so much, dear colleagues. Any other question, comments, discussion? So then we are thanking Anton for his presentation, and it was last presentation in our session. I want to thanking all of us for a very interesting discussion. We saw 24 very interesting presentations, and I believe that result what we obtained in our research will helpful for our sustainable energy and sustainable future in general. So thanking all, and we'll be glad to meet you in our next conference.
Thank you for conference. Goodbye.
Thank you.
Thank you.
Bye.
James.